In this course, you'll dive into deploying Expressjs and Node.js applications on AWS Lambda using Neon, Serverless, Postgres, and the Serverless framework. By the end of this course, you'll also learn how to adapt your deployment for Vercel alongside mastering database setup, migrations, GitHub actions, and more. Justin Mitchell developed this course. Justin has created many excellent courses on his Coding for Entrepreneurs course platform and his YouTube channel. Neon provided a grant to make this course possible.
Hello and welcome to the Serverless Node.js API course. In this one, we are going to learn about Expressjs to build what's called a REST API. Now, we're really going to be building a JavaScript application that runs on the back end in a serverless environment, which really means that we just focus on our code. We don't have to focus on the servers at all. Now, traditionally speaking, when it comes to serverless, a big challenge that comes up is what database to use and how do we actually connect to it. Now for that, we're going to be using Neon and Serverless Postgres. Neon is actually paving the way for so many applications to leverage serverless databases as well. And of course, they are a partner in this course, but the idea here is we need an application that we can scale up or scale down as needed. And we'll do that using AWS Lambda serverless functions. But then we will also need our database to match that scaling up and scaling down. And that's where Neon comes in. But it gets better than that. What we can do is we can also have multiple versions of our application deployed so we can do these iterations, share them with other people, and test out little pieces of it while also simultaneously having our database made and ready for that. Neon does this really cool thing to branch data at any given time. You can look at a point in time and branch it so you can work on multiple versions of your application at once and allow people to use it without having major overhead to make all of this work. It's fantastic. It's a really straightforward way to do all of this. Now, the idea here is really going back into focusing on the code and being able to iterate as much and as fast as we possibly can. So sure, we are going to be deploying an API service itself, but that's really just for a foundational piece so we can actually focus on getting our code better and better and better over time. So this is really about setting that foundation, and serverless is the perfect way to do it. So let's talk a little bit more about why serverless is important and why you should care about it. Let's talk about what serverless means for your application and why you should consider using it. First and foremost, it's all about focusing just on the code and effectively running that code. Now, the best analogy I have is lights, like quite literally the lights in your room. Right? So when you walk into your room, you turn your lights on. When you walk out, you turn them off, right? But what if you forget to turn them off? Well, they just keep running whether or not you're using those lights or not. Serverless is just like that. Now, a normal server application, you turn the server on when you want it to run, and you could leave it running forever. That doesn't mean it's being used all the time, but it does mean that it's running forever. Now, of course, there's a lot of costs associated to that to have it run forever because computers just have a bunch of teeny little lights that's how it works, right? But the idea being that if you leave it on, it's going to continue to run always. But there's another part of this is like, what if you have just a small little light turned on? Maybe it's just your desk light, and that's the light that you have on. And then when you leave, that desk light is still on. But then 100 people walk into the room, that desk light is not going to light up the room. You'll need a lot more lights to do that, and therefore you would have to scale your lights up. Now, it's not any different in a server environment. When you have one server, yes, you can have a tiny server that maybe costs a few bucks a month to actually run your application. But as soon as you get thousands of people trying to access that server, well, you're going to need to scale up. You're going to need to load balance across all of these different other servers, which means that you'll have to actually understand the infrastructure behind it. You'll have to learn how to scale those things up. Now, don't get me wrong. I find that stuff really fascinating, and it's something that I really like doing. It's a fun orchestration. But the thing is, not everyone's ready for that or is interested in doing that, especially with business critical applications. Maybe you don't want to manage those servers. And so that's where these serverless services come in. Serverless is really just focusing on the code. You deploy your code, and then somebody else makes sure that all of the systems scale up to meet the demand. And all that scaling happens automatically. But when you use something like AWS Lambda, you just focus on making sure your code runs. And then once it does run, you can deploy it to Lambda. Lambda will scale up and scale down to meet request demands. Now, Lambda isn't the only serverless service that's out there. There are other serverless options, but Lambda is a great one. It's one that helped pioneer so much of what we take for granted with serverless today. So it's actually really great. But actually deploying to Lambda presents a few problems for us. Number one, deploying directly to Lambda with code is tricky. There's a lot of different things that we need to consider with doing that. And if you don't know AWS, it becomes even more tricky because there's a lot to AWS. And that's where we use something like this serverless framework. We really just use the open source framework to help orchestrate the deployment to Lambda so that it's only a few commands instead of trying to figure out a bunch of commands in there. Now, there are things that we will discuss in terms of IAM or access policies and all that with serverless and AWS. But it actually is fairly straightforward with serverless. I've seen a lot of different services over the years that deploy to AWS Lambda. I can honestly say that serverless is one of the best, if not the best way to do it, specifically for Lambda and what we're trying to do with Node.js. Now, the other part that comes as a challenge when it does deploy a serverless application, the serverless application typically doesn't interact well with databases because databases themselves historically are always on. That's because they pretty much always need to be available to grab that data. So traditionally speaking, that's what they do. And the reason we're using Neon, Neon is pioneering this serverless for databases and specifically for SQL databases and Postgres. Postgres is probably the most used database in the world. And so a serverless Postgres really just unlocks this for your database as well. So in addition to your code application, your database is going to do that as well. Now, there's a huge advantage as to having serverless databases as well as this point-in-time branching. So what's going to happen is whenever you need a copy of your database, with Neon, you can just branch it just like you would with your code, and it will actually make a point-in-time copy of that data. So then you can actually stage your application many, many different times. So if you're working on version 10 or version 1 and all of the versions in between, you can actually create different branches of that in your database, do the migrations, make the changes that you need for your database all right there. And all of this is possible because of how they approach serverless and how easy they make it for your applications to run and consume all of this stuff. So that's really what we're going to be doing, is orchestrating all these things together. Now, I realize it might sound complicated, but it's actually fairly straightforward thanks to both AWS Lambda and Neon. Really, you just focus on your code and you just pass in the case of Neon, you're going to have a database URL string that Expressjs will consume using the Neon serverless package that works with JavaScript. So it's actually fairly straightforward. There are some moving parts. So yeah, you probably want to know some JavaScript to get this going, but we'll talk about that in just a moment. But that's a high level understanding of why serverless in the first place. It's far more effective. It's far more efficient than managing a server yourself. Now, of course, if you're not ready to really scale up your application and you're not ready to build into this environment, you can still bring around the Expressjs application and your Neon application or your Neon database with you to wherever you want to deploy. It doesn't have to be serverless. And so we actually do take a look at how to deploy this on Vercel for that very reason, is so you can see how portable it can be by leveraging a managed database service, in this case, a serverless one that ends up costing significantly less. So I'm really excited to get into this one. So let's go ahead and take a look at this course. Let's talk about the requirements you'll need to do well in this course, and then we'll also do a high-level overview of what it is we're going to be using, what technology we're going to be using. Now, first and foremost, this is a JavaScript-heavy series, so that means that you need to know stuff like functions, classes, objects, arrays, string substitution, handling promises and callbacks, maybe even JSON. Once you know that stuff in JavaScript, then you can move to the next part, which is using Node.js or server-side JavaScript. So be sure to install Node.js, grab 20 LTS. So version 20 is the version we're going to be using, but whatever version you end up using, make sure it's an LTS one, unless of course you know what you're doing. But the idea here is we're going to be using Node.js to actually run our JavaScript. So we'll create a JavaScript file and then use Node to run it. Now, if you're from the browser world of JavaScript, as in writing stuff like React or Vanilla.js, Node.js is just on the server side. Your web browser won't run your JavaScript. Node.js will, although they work basically the same, which is one of the magics of Node.js. So once we actually have our application running locally, we'll start to deploy it to a serverless function called AWS Lambda. Now, at a high level, serverless just means that it runs when it needs to. That's what we're going to be using AWS Lambda for, and that's how they can offer things like 1 million requests free per month on their free tier. which is amazing. That's so many requests to pay $0 for. So the next part of this, of course, is not just running the actual code itself, but also storing the data that we need to store. And for that, we're going to be using serverless Postgres for this, thanks to Neon. Neon is really pioneering the next generation of what Postgres can be by implementing things like serverless and many other features to make it a very, very powerful offering for your applications. This is very, very straightforward, as we'll see, but the idea here is these are going to work in tandem to have a fully serverless application from the actual Node.js side of it itself, as well as our database. It's fantastic. Then to actually build and deploy the application, we're going to be using GitHub, and more specifically GitHub Actions, to have a serverless part of that as well. That's going to handle so much of that. So if you don't know Git, definitely brush up on that as well. Now, finally, the main part of AWS that we're going to be using really is AWS IAM. This is because of the tools that we'll use. We really just have to focus how to make the right policies to do the deployments itself. We're not going to have to manually deploy to AWS Lambda because that's kind of tricky and it takes a long time to configure, when we can really just automate the process and really only focus on the IAM access, the policies, all of that. That's one of the things that we'll be doing for sure. So make sure that you already have an account on AWS, and also that you already have an account on Neon, and all of those links are in the description, of course, and then definitely sign up for GitHub as well. Now, a couple optional things that we'll do towards the end are deploying to Vercel. So deploying to Vercel is going to basically take everything that we did for AWS Lambda and then deploy it on Vercel. And that's really where we're going to wrap things up to really just see how portable we can make this application. And of course, when we deploy to Vercel, we will still be using Neon, our serverless database. So that's going to be very, very straightforward. So we can see how we can really move the code around without doing much to our database, which is really nice to keep that integrity. Now, the final thing that's optional is actually using Visual Studio Code, or VS Code. This is the text editor I like using the most. To me, it's by far the best one that is also free. So if you have one that you prefer, by all means, go ahead and use that one. I'm going to be using Visual Studio Code. So with all those requirements out of the way, let's go ahead and jump into actually building out our project, of course, with Node.js already installed, which we'll verify when we build out that project as well. Now, when it comes to building for AWS Lambda, one of the key things we have to think about is how do we actually even test or develop locally for a serverless function? And the way we're going to do this is by using the serverless framework from serverless.com. Now, this framework is going to make it easy for us to test locally as well as deploy into production. But before we even get there, we need to jump into the AWS console to just verify which version of Node.js we should even use. I know I mentioned that we should download and install the LTS one in the last part, but we want to verify that that LTS is even available in Lambda itself. So if we go into AWS, into Lambda, you can do a quick search for Lambda as well. We're going to go ahead and hit create function. And in here, we just want to look at the runtime and the runtimes that are available right now. As we see, there are a number of them on there. I would say Node and Python are probably among the most popular ones there. But the idea is Node 20 is available, and therefore the one that is the current LTS is also available. So download what's available there so we can actually test it out locally. And so in my case, I've got the Node version 20. There it is. I've got npm 10, which comes in with Node version 20. And then I've got the serverless framework is what I want to use to actually test out AWS Lambda. We're also going to use serverless to create our project. That's what we want to do now, is we're going to use that package to create a project. So to do this, we're going to do npm install -g serverless, and this will install that serverless package for us. In my case, I already actually have it installed, so it's actually pretty fast. But the idea then is once we have serverless, there's a lot of different frameworks that we can use from it. So it has a lot of different features in here as well, many of which we are not going to cover at all. But this is what we're going to do. We're going to create a new serverless project, and then we're going to navigate into that directory, and then we'll actually bring it into our VS Code instance. So to do this, I'm going to navigate into a location where I like to store my projects, which in my case is in the dev folder, and we'll call serverless right here, hit enter. Okay. And so what we should see now is different kinds of serverless functions we might want to build out. And so what I'm going to be doing is the Express API one. And this is just to get some pure Expressjs built out for us, or the package for us. I'm going to go ahead and save that, and I'm going to call this my serverless Node.js API. Okay, and so it's going off of the Node Express and all that. I'm not going to register a login for the serverless framework. I don't need to do that, and I'm also not going to deploy right now. In fact, I don't really have a way to deploy yet, and so we will worry about that when we get there. But for now, what I want to do is I want to navigate into this serverless Node.js API, and we're going to go ahead and open this up into VS Code, just like this. And so I'll go ahead and start off and save this as a workspace, and then I'll also do my git init. Definitely want to make sure that I have that. Notice there's already a git ignore file in here, so it's not something I need to worry about just yet. Next thing, what I want to do is prepare this to work with the correct Postgres. So when it comes to Postgres databases, you need to have a client of some kind to connect to that Postgres database. So traditionally speaking, you might use something like Node Postgres. Node Postgres is a fantastic package that makes it really easy for something like Expressjs to connect to a Postgres database, which works really well when the Node application is continuously running. Even if it's updated and it has some downtime, overall it would be continuously running, right? And so when it comes to something like AWS Lambda, it's doing the opposite of that. It's only running when it needs to run, and therefore it's going to be down a lot. And so that's where something like Node Postgres isn't well positioned to make that happen. Maybe at some point it will be, but the thing is, Neon actually pioneered Neon Serverless, this actual database, which is ideal for serverless and edge deployments using HTTPS and WebSockets. So that persistent connection can be interrupted on a regular basis because of these two things, and therefore is very well suited for any kind of serverless, including AWS Lambda. And it also can use persistent connections because it's a drop-in replacement for that Node Postgres package. And it's also what this is based on. But again, it's designed for this modern serverless architecture that AWS Lambda has, that we've seen in a lot of different places as well. And so that's the actual package we'll end up using to connect to our database. And of course, our database is also provided by Neon. But the idea here is we definitely need to use this Postgres package, or this Postgres driver and client, to be able to connect our Expressjs application to it. So let's go ahead and install this as well. I'll go ahead and use the npm install command as well. So we'll install this into our application. And while we're at it, we're also going to go ahead and do npm install-g, and it's going to be the Neon command line tool. So we'll use this to use all sorts of things related to Neon. And so with that installed, I'll also go ahead and do Neon CTL and auth, so I can actually log in to Neon and verify my local machine on this to do all of these sorts of things, which in my case, I'll go ahead and authorize. You can also use an API token, which is something we will do when we get into the GitHub actions of it all, and we can see where those credentials are saved right there. Okay, so we now have our baseline project set up, right? It's ready to go, and overall, there are still a few other installations that I want to bring in, and those are related to how we connect to our database and how we manage our database's schema. So this is going to be done using Drizzle ORM and DrizzleKit. Both of these things will be installed right now, so let's go ahead and install DrizzleKit ORM. And then we'll go ahead and install DrizzleKit. And to do this, we'll do npm install -D drizzle-kit, and go ahead and install that as well, which it might have actually done with Drizzle. It did not. So DrizzleKit will be used as well to help us with our migrations. The Drizzle ORM will help us design out our schema once we get to that portion. But these are the main packages we're going to be using. If we need to add any later, we will. But overall, for right now, this is what we're going to start with. And we really need to see how to do a hello world with this serverless package and see exactly what that's going to look like in conjunction with our Neon database when we get there. In a standard server environment, the way you run Expressjs is by modifying what we have here by using app.listen. And then we can pass in some sort of port value here. And this port value then can have a callback function once it actually starts running. And you can do something like console log and then running at http://localhost 3000, right? And so what this will allow us to do then is to open up our terminal, and we can now run node index.js. Now, before I even look at that, I'll close it out and turn that off. I'll comment that out again and run it again, and we see it goes away. This is actually a good way to think of serverless, right? So the first version, this is going to continuously run no matter what. The second version is running when we tell it to run. And the way we restart the first version is, well, quite literally restarting the application itself and then making sure it runs. So now we've got that, let's go ahead and take a look at that homepage. And we can do that by going into our web browser. We could also open up a new terminal window, and we could just run curl http://localhost and 3000, and that will give us the same response back. Great, so that's showing us that Expressjs is working, and in some sense, it's actually a hello world from Expressjs. But of course, I want to make sure that my serverless app is actually working and I can use it locally. So the way we do that, of course, is by commenting out this app.listen. This is for like a server full app, which we are not using, right? And so let's go ahead and close out this node index.js. And so what we want to do is we need to update our local environment to handle the offline mode from the serverless framework. To do this, we're going to go ahead and use serverless plugin install -in serverless -offline. Okay, so once we install that, it should open up and install something into package.json related to the serverless offline package. And again, this is for development mode, so we can emulate what the actual AWS Lambda serverless would end up doing. And so to actually run this, we can use serverless offline now, and that will trigger the exact same application, and it's running at the same port in this case. So if I went ahead and run this again, I get the exact same value, except now it's going based off of an AWS Lambda event, or it's emulating exactly what that is. It even shows you the build duration for this request. Now, another thing that's cool about this is it can also emulate different regions. So if we wanted to run that with a different region, so like region and US West 1, you could do that. And that would actually show you this different region. We can also do different stages, which allows us for a lot of options here. So if I do region or rather stage and prod and hit enter, I have just another stage that I can work off of. And of course, we're going to build this out quite a bit more throughout this course. But the idea now is I have a really quick and easy way to test this serverless application itself. But there's still some things that I need to modify. The first one is going to be package.json. What I want in here is the scripts definition, so we can actually call out those scripts that we might want, like dev, and this is going to be just simply serverless offline. And you can add in the stage of, let's go ahead and say dev, for example. The region in this case doesn't really matter that much, but I'll go ahead and leave it like that. That way I can do npm run dev, and then it's still the same thing, and it's still working just as it was before, but then I don't have to remember all of the commands related to this serverless offline. That's a big part of the reason I use scripts like this. There are other reasons as well, but again, we're just sort of preparing for development mode at this point. So the next thing is going into serverless YAML. So what you might see right off the bat is, well, yes, it added this plugins here. Perhaps you looked at this file, perhaps not. If you haven't looked at this file, we see this functions in here, this function handler. We'll talk about that in a second. But then I also have this big red flag, which is this right here. That is showing us the runtime Node.js 18. This is not the runtime we want. Now, to remember what runtimes we have available to us, we can log into the console on AWS, and we can navigate into Lambda, and then go into create function, and going down to what's listed here, right? So we have other options on here. Now, we've already talked about it, but 20.x should be the runtime we are targeting here. So we're going to go ahead and save that. We'll run this again. In this case, it doesn't actually change anything. It doesn't change anything technically from how this is running, because Node 18 and Node 20 aren't a whole lot different. But at the point of this is to make sure that our runtime is matching our development mode and our production mode. That's really the point there. The next one I want to do is change how my API handler is working. So the API handler is really just looking for this index.handler, which in our case is coming from the serverless application itself. and then this module right here that's exporting handler, that is what we're end up using. So we've got is index.handler. If I change this to app.handler, I would need to change index to app.js, right? And you might end up doing that. Now in my case, what I usually do is I create a file called src. So src, a folder there, and then I move my app inside of src. Now, it's probably a good idea to just keep it in as just index.js. Our application itself is not going to get that complicated, so we're going to leave it as index.js. But with this, it actually separates my application code from a lot of the configuration for the project itself, which is what I always do. And so back into this serverless.yaml, we can now just change this handler then into src.index.handler, right? And so that's going based off of the folders themselves. So let's go ahead and save that, and let's try that again with this run dev. In this case, I can go ahead and run it again, and now I get a problem in here. So let's go ahead and change the actual handler to actually doing not dot notation, but using the folder itself. And so we'll run it again. This time it works correctly. Okay, so that dot notation is the intuition I would typically use to run some sort of handler like this, but it's important to be able to test these things out, try them out, and see exactly how to configure this. So now we can actually start developing with this serverless offline framework. It's really just that simple. I don't think there's a whole lot more we need to talk about this in terms of getting the serverless offline working. Now, I will say that you could probably experiment with a lot of things related to just doing your server full app. That's probably going to be okay. And realistically, I wonder if we could have that server full app in here with the handler itself, if that causes any issues. And it doesn't appear so, mostly because of the export itself. The actual namespace for that export is what's being used. It's not actually calling index.js like this app listen would end up doing. So basically we have support for either one, which is also pretty nice. Okay, so now that we've got this, let's go ahead and see how we can load in environment variables into our application right off the bat. At this point in your coding journey, you probably realize that it's not a good idea to hard code API keys, database strings, or really any secret data right inside of the code itself. It's much better to inject that when the code runs, so have it done in the environment itself. And the way we're going to do that is by using a .env file. This is very, very common to do in all sorts of programming languages. But the idea here is in index.js, if I did something like database URL, we don't want to have the actual database URL string in here. We want that to be abstracted away. And so the way we're going to do this is by using process.env. So what we have here is process.env dot, and then the environment variable we want to use. In our case, it's going to be database URL. So if I save that as is and then run our serverless application, our offline, and then curl to it, what I'll get is this hello world here. Looks like maybe I didn't save anything, so let me try that again with that curl. I'm still not getting anything for this. So let's go ahead and actually change this a little bit more and then go ahead and say something like not here. Okay, so now we've got, if it is there, it will be set. Otherwise, we'll just have it as not here. We'll go ahead and rerun our serverless application. And now I get this database URL not here. Of course, this is just a fallback value, not something we'll necessarily use for much longer. But the idea is that we want to actually have this work. And so that's what we'll do now. Now, traditionally speaking, you might use something like the .env package. This is a fantastic package and is used a ton. So this is something you would absolutely consider using when it comes to, well, non-AWS Lambda services. We want to prepare it for AWS Lambda. And the way we're going to do that is by using the serverless.env plugin. It's a fairly straightforward plugin, and it allows for a lot of different support, as we'll see right now. So the idea is we want this database URL to work. And the way we can do that is by coming into our serverless.yaml, and we can define our environment. And so in this environment, I can add in our database URL here, and I can set it equal to env colon, as in the environment colon, and then the actual value we want to set from the .env file, like that. I can also have a fallback, like that. Okay, great. So this is sort of configuring it, but we still need to add in the plugin itself. So let's go ahead and close out this server, and now we're going to go ahead and run serverless plugin install -in serverless -.env -plugin. hit enter, and this will install something in our serverless.yaml as well as package.json will be this right here. And so now that we've got that, we can come back into serverless.yaml. We see that this is one of the plugins that's available to us, which of course will be very useful when we actually push this into production. Then I also want to add in use.env being true. So we'll go ahead and save that. And I just want to see if the fallback value shows up, if the .env value shows up, or if the inline code value shows up. So let's go ahead and try this out by running it again. I don't need to reinstall. I'll just go ahead and run npm run dev, and then we'll run our curl command, and we got something else in here. So what's happening in our serverless.yaml, its fallback value is actually not being used, but rather the .env value is being used. So at this time in my gitignore, I want to actually add in .env here with a star at the end, because what I can also do is .env, let's say for instance, .dev, as in my development mode. This is another value that I might have, so we'll go ahead and say dev.db, right? And so then if I wanted to use this dev mode here, I could go in package.json and quite literally change the stage to dev mode, which I still have. It's actually on that stage. So this dev right here, if I called it dev abc, I would want to change this .env to .dev abc type of thing, right? So that stage is how I can actually modify this a little bit, which is also super nice. And it actually will help prepare us for our local environment, for our staging environment, and then finally for our production environment. We could quite literally have all of those environment variables in here and then just call the different stage to run the different environment variable, which we can test out really quickly right now. What we see is that database URL coming through. Fantastic. So the next thing is like maybe we want to add in another environment variable. I'm going to go ahead and say debug, and we're going to set this equal to 1. So this is now in my .env. Back into serverless.yaml, I'm going to go ahead and do something similar. And this time I'll go ahead and say debug, and we'll go ahead and come in here. This time I'm going to give the fallback value of 0. And so now in index.js, I'll go ahead and add that in as well, and debug. And this time I'll just go ahead and leave it like that. Save it. And actually I'll go ahead and say it's equal to 1. So debug being equal to 1 based off of .env. Let's go ahead and save that. We'll restart everything. And let's run it again. This time I'll curl again. And what we've got is false, right? So env is not equal to 1. Let's go ahead and see if it's equal to, or what it is equal to. Let's just console log it like that. I'll go ahead and restart the application itself. We'll run it. And my console log is 1. What just happened here? Well, let's actually try it, or equal to the string of 1. And let's see what that looks like. So I'll go ahead and just put it in as a string value here. And maybe we wrap this whole thing in a string as well. Now let's go ahead and try this again, rerun this, and run that again. And now we get true. So the actual values themselves are often going to be treated as a string itself. So you need to be aware of that when you're going through and using environment variables inside of your Express application. Now, there are more advanced usages of the actual plugin itself, which I do encourage you to go into the Serverless Frameworks plugin documentation for that, and you can see all of the advanced usage that's in here. But generally speaking, what we want to know about are 3 main things. One is we have to define the environment variables in serverless.yaml that we're going to use in our application. 2, we can use different .env files to actually load in those environment variables. And those .env files can be as simple as just the standard .env, or, of course, based off of any given stage that we might want to have. Dev, test, prod, v1, v2. And then each stage can still inherit from that base.env, which means that we don't have to rewrite all of the same variables over and over and over again. Like in the case of debug, maybe we just want it always to be 1, so that all of the other stages can just go based off of 1 because we're in our local development environment, and especially because these .env files would never be committed to the Git repo. And then, of course, in the final one, our code itself needs to be aware of when the actual data types don't work as you might expect. So that's another thing that's just to be aware of when it comes to using those environment variables. And so at this point, we now have a way to test out our application altogether. Notice that when I did change the .env dev, the actual stage environment variable, then the actual value came through. So this actually overrode what was in the first one, the .env itself, which is also pretty nice. Great, so now that we've got this, we're really just ready to start actually using that database URL. We start the integration process with our Neon Postgres database. So let's start that process now. Now we're going to take a look at Neon Serverless Postgres. Now what I want to show you here is the console on Neon so we can really highlight what branching is all about. It's that point-in-time snapshot of our database that we can essentially use a brand new copy of it isolated from the original one, which is great for production applications and then staging instances or versions of our application. And it happens really, really quickly. So of course we get all the benefits of serverless as well. So it actually scales down to 0 and then it'll scale up to meet demand as well our application needs it. Now the latency to actually scale from 0 to 1 is surprisingly incredibly fast with Neon as well. So go ahead and go to neon.tech and sign up right now. And you're going to go into the console and it's going to look something like this. So at this point, we need to create a brand new project, which will house our database and all of the branches of it, or all of the copies of it. And so let's go ahead and do that now. I'm going to call my database project the Serverless Node.js app or API, either one. Then I'm going to go ahead and use Postgres version 16, which we have other versions as well. I'm going to go ahead and use the default database name, but feel free to change this as you see fit. The last most important part is the region itself. This region should be as near to your application as possible. Now in our case, we're going to be using the default, which is US East Ohio, at least that's my default. And the reason for this is because it's going to be where we deploy our application on AWS. And of course, that region of Ohio is where we're deploying to US East 2 in AWS, which we'll come back to once we actually deploy that. But the idea here is we want to start off with our database being in that region. Now it's actually really easy to create a new project with a new region. So if you have to, you could always just use whatever region is physically closest to you right now. And then when you actually start deploying your application, you'll go ahead and change the region then. Okay, so at this point, let's go ahead and create that project. And what we get right out of the gates is a connection string. This is a Postgres connection string that gives us our username, our password, our host, our database, and a few other configuration items. Now, the other thing that's really cool about this when you first start out is you've got a lot of options for integration in here, right? And there is one for Node.js, but we are actually not going to use this integration option. We don't need to for a number of reasons. One of them being that we will just use that connection string. That's what we want. So basically what we'll do is copy this string, whatever it ends up being. You can click copy right here, and then you'll bring it back into your local project, into the environment variables when we did the .env stuff, and you'll paste this in. And this is what we'll end up loading in once we get there. For now, I'm going to leave it just as a, the original dev DB thing, but the idea being that eventually we'll use this string. For now, though, what I want to do is I actually want to play around with branching inside of our project. So let's go ahead and close out this window here. Of course, we can still get all of that data right in the dashboard also. But what we want to do is we want to actually insert some data into our database. Now, of course, if we look at our tables here, we have no tables yet. There's really nothing in our database. So let's go ahead and add some just by using the SQL editor that just gives us some default code that we can just run that will actually insert some data in for us. And so what we'll see is if I go back into the tables tab, I now see there's a table in here in which I can select and actually see the data that's coming through from that. And so we could also just run that a few more times by going into our history here. I can just run a couple lines here by selecting it. I'm going to run that, run it again, just so we have some more data that we are playing with just like that. So I've got 40 rows in here right now. So let's take a look at the magic of branching. So if I go in this branches area here, I'm going to go ahead and create a new branch, and I'm going to call this my dev branch. So current point in time, that's what we're going to go off of, but notice we've got other options in here. We can also select which branch we want to be the parent, the one that we're basically copying from. I'm going to go ahead and create this new branch from my main branch because that's the only one I have. And now I get another connection string. This is a different version of the exact same data, but it's a brand new and unique connection string that I can use in my project specifically for like a dev branch that has a lot of the same data. So let's actually just verify that real quick by going back into that SQL editor. And now what we want to do is just switch our branches to our dev branch. I'm going to go ahead and run those 2 lines once again. And now I'm going to go and run it. And let's run it again. And what we'll see is if I go into my tables, once again, I'll change the branch or make sure that I'm on a new branch. I'll select the table that I just was playing with. I'll scroll to the bottom and notice that I have 60 items in here now. And if I were to go back into the main branch, which I can do that quickly, select it again, and now we see once again the main branch still is back at that 40 amount of items or 40 rows in there. And it happens just that quickly. But the other thing that's great about this is if at any time we feel like deleting this, I'll just go ahead and copy the name, go ahead and delete this, delete it. Now that project is completely deleted. So what we can do, of course, is just bring it right back. Now, of course, this is going to be an empty project with empty databases, but overall it's the same configuration, just it doesn't have the data, and I can spin it back up that quickly. So of course, actually bringing this back to what we just looked at, I would just need to go back into that SQL editor and create those tables. Of course, before I created tables, I could just verify that, yeah, it actually is an empty database, which no surprise it is, like that kind of makes sense. But the idea being that if I come back into the SQL editor, I were to run it again and maybe again, and let's say, for instance, I wanted to create a new branch. Once again, I'll go into branches, create a new branch, dev branch from the main branch. I'll go ahead and create that. And then we'll go ahead and go into, well, let's create another branch. We'll create one from the dev branch. We'll go ahead and do dev v2, right? You can create as many branches as you really need. I mean, my project in this case has a limit of 10, but you're probably never going to go past 10. That'd be surprising if you ever did. But the idea, of course, is that we have all these different branches. So I can go back into the SQL editor once again and run a few commands for the various branches that I see fit. And it just is that fast. It's so cool. And it makes things really, really easy. And granted, there's a lot of other configurations we might consider, like new roles, new databases. These things get a little bit more advanced on the Postgres side itself. But overall, there are other options that we can implement. Now, one of the main ones that we want to implement is, well, basically doing these things in an automated fashion. And we will do that using the command line tool later, the Neon command line tool that will actually build up our branches. It will do the branching for us. It won't necessarily run SQL directly with the command line tool because that's not what we're going to be using it for. Instead, you'll use a connection string to run the various SQL commands itself. And then what we will also do is we'll implement the API keys. So inside of developer settings here, we're going to generate a new API and then use the command line tool specifically for that so that so much of what we just did will be automated. You can also even automate the project itself, which is something we're not going to do, but we will automate the process of branching because it is a fundamental part that really just unleashes a lot of value that we can provide to our development process, right? So whenever I need to actually have a dev version or dev v2, I can still use production data if I want to, or I can just build out data that I need just for local testing, and that data could be in its own branch of our original database. And so then when we run migrations, we can migrate each database as we see fit, as in change the structure of the database whenever we need to on each branch as well. So that part's also pretty cool. But overall, the idea here is if you actually let it sit for a little bit longer, what's going to happen is these are not going to be active anymore. And so that the actual databases will be ready to be used, but they'll just become inactive. And then actually reusing them or making any sort of call on these databases will spin them back up to meet the demand that you need, as we'll see as well once we actually start implementing this database into our project. So at this point, go ahead and clean up the branches, delete the ones that you don't need. I'm going to be going just off of the main branch, and we'll start integrating that into our project here in just a little bit. Let's take a look at how to use the Neon command line tool to automate generating branches as well as getting our connection strings, and then of course deleting branches when we need. So the way we're going to do this is by starting from scratch. We're going to create a brand new project. I already deleted that project. And then, of course, we're going to use the command line tool, which there's a lot of documentation on it. We're only really scratching the surface here and doing a few of the primary actions that I've been using. So to do this, we want to make sure that the Neon CTL is installed. In my case, it is. And then I can also use just straight up Neon. And if you remember, we used this npm install-g Neon CTL. That was actually how I went about installing it. Now, at one point, I will use something called JQ, which really just helps me parse JSON data, as you'll see. And to install that, it's brew install JQ. This is absolutely optional, but it's one more thing that you could potentially use to automate. Okay, so once you actually have it installed, you definitely want to run through Neon CTL auth. Now, I already actually authenticated this. I did all of this earlier, so if you haven't done that, go ahead and do that now and make sure that you have access to your local project. Now, in my case, if I actually go into Neon CTL projects and list, hit enter, what I will see is absolutely nothing. I actually deleted my project, and it's really simple. So to create one, let's go ahead and create one real quick with a name here. And I'm going to call this Serverless and Node.js-API. Now, this name flag, it's pretty straightforward as far as how to create something. I go ahead and create it, and there we go. I get all of the data that I might want, including our connection URI or connection string that we can use to actually connect to this. We're not going to use that yet. Instead, what we're going to do is just delete this project. I'm going to go ahead and copy this restless rice here, and we'll go ahead and do neon CTL projects delete and use that ID, and that will actually delete that project itself. So then when I go to list everything out again, I get nothing. Right? And so that's really that simple to create a project and delete a project. Being that it is that simple, we need to be aware that yes, you could absolutely accidentally delete a project that you didn't want to delete. But in our case, we're going to stick with just this for now. And so I have my project created and I already have this connection URI. Now what I can do is I can actually run neon CTL and connection string, hit enter, and this will give me that same connection string. Right? And so I can use this within the PSQL, the actual local client that I have. I can use that connection string, and it's PSQL, not PQSL, but we can use that connection string just like that, and it will allow me to jump into this like something like select now. And I can run that, and it will give me the exact time that it is, and we can quit out of here in a number of different ways. You can write out quit, you can write out exit. It's actually pretty flexible as to how Postgres works these days. So that's the connection string. So let's go back up. There it is. And so I can use it in many different ways. Now, the other idea is if we needed another branch, right? So if we were going to create a branch, let's take a look at that. So neon CTL and then branches get, and actually let's go ahead and do branches list first. We can see all of these things. So to me, the format works much like Kubernetes, if you're familiar with that. But the idea is you get the neon CTL or just neon, the actual resource that you're looking for, and then the action you want to do, right? So it's going to be get, list, delete, right? Or create. And then in this case, so we've got branches. And if we do get, and let's go ahead and grab this ID here and paste it in, we get that particular branch. If we go neon CTL branches create, well, let's go ahead and create a new one. I'll go ahead and just write out dev, unknown command dev. Now, just like with our project, we use -- name and hit dev, and then we get a name. So the name and the ID are not the same, right? So we've got the ID here, which, what do you know? That ID is also corresponding to the actual connection string itself. But once again, if I go to list out all of the branches, I can see the various branches in here. If I do neon and CTL branches get, let's say dev, once again, now I can actually call dev, right? So when I go to create it, I need to pass in the name argument. If I don't create it, I don't have to do that. The other thing is when we create one, let's go ahead and just not have a name argument at all. And what do you know? It actually creates one for us. So it'll actually come up with its own name, and we can list all of those things out just like that. So then if we want the connection string, we can use neon CTL connection string and then pass in the branch that we are looking for. So we can use the auto-generated one that the name and the ID look to correspond, or we can use our own. Let's go ahead and use dev in this case. That branch should be different than the main branch, right? And sure enough, it is, right? So the user that's being created is not different, and we could absolutely create different users to actually run this connection, which you could just verify inside of here as well. there's these different roles in here that you can create for any given user. That takes some extra that we'd have to do in the Postgres side as far as their permissions and whatnot, whereas this user has full permission to the database itself. But the idea here is now we can create branches really quickly, we can create connection strings really quickly, and then of course we can actually use those connection strings. So in the case of Linux and Mac, you can export, let's say for instance, our database URL. We can set this equal to that Neon command. So Neon CTL connection string, and then you could do our branch of dev, something like that. You hit enter, that will run that command. Now I can use this connection string with the PSQL like this. And let's make sure that we have this in double quotes, actually, not single quotes. And there we go. So now I'm actually able to connect and hide the database URL, as that is one of those key things that you would want to do. And so when it comes to Postgres itself, the different clients, actually downloading and installing PSQL is something that I recommend you do if you want to learn more about Postgres itself. So using that SQL editor like we saw before, we had all of this stuff. I can absolutely do that inside of Postgres SQL, right? So I'd go line by line to just make it simple. We've got this example here. We created that table, and then I can go ahead and bring in some of those values again. Once again, it's doing that. And then I can select all and see all of those values right here. So that's really how you can do the second part of what we were doing within the console itself of the SQL editor. You would actually have to use a Postgres client of some kind. Now we can do a lot of these same sort of things within the actual JavaScript itself. We could call SQL queries inside of the JavaScript itself, as we'll see here very shortly. But the idea overall is that we have the ability to automate so much of this. Being able to create branches on a whim is really great, because then when we are actually committing our code, we can create those branches, get the connection strings, and deploy it wherever we need to with that stage and all that. So it just really lends really well for automation and staging purposes for many, many different stages, which is why I wanted to show you this. Now, again, this is foundational for what we'll do later, but overall, I recommend playing around with this and being comfortable with just deleting assets whenever you feel like it. So in the case of our project, Neon projects, right? So we can do Neon projects list rather, and we can go ahead and delete this project and then start again, right? So Neon project delete, and you get that ID. Now in this case, I only have the ability to create one project. Let's go ahead and just try create, hit enter. Notice it creates one for me. I try to create another one. I got my limit exceeded, right? So I can really only create one project, but within that project, you can create multiple databases as you could, experiment with on your own in there as well. So if you wanted a multiple databases, with multiple branches, what you would do is you would have multiple branches. Each branch can have its own database itself. So the project can have multiple branches. Each branch can have multiple databases, or they can just have all the same sort of things. So that's pretty cool as well. So yeah, if you have any questions on the Neon command line tool, definitely consult this reference here. There's a lot that it's just a matter of playing around with it to get the most out of it. And then, of course, downloading and installing some sort of Postgres client so you can really get your hands dirty with the SQL if that's what you're wanting to do. And if you're not wanting to do that, if you're wanting to get using JavaScript, that is what we need to do now. It's time to actually integrate our Neon connection string, that database URL, and also the Neon serverless package into our Node.js application so we can do a lot of these things with now heavy JavaScript. So let's take a look at how to do that. Now we're going to go ahead and integrate our Node.js application with our Neon Postgres database. The key part of all of this is the fact that we are using serverless. So the way we approach it has to be from a serverless perspective, and that's how we have to configure things, which means that we're going to be using the very specific package of Neon database / serverless. There are a lot of Postgres packages out there to integrate with Node.js. Specifically, Node-Postgres could be one that you would end up using. But the important part for us, as we've said before, is that we are using serverless and we need to use the Neon version of that serverless. So the first thing that I want to do is I want to grab that database URL wherever that might be. So in my case, you can go into the Neon console, grab the database URL that's right here, or we can use the Neon CTL connection string as well. right? So you can always create a new project if you don't already have one. I'm going to go ahead and grab this connection string right here and bring it into my env dev file. Not just .env, but rather just .dev. So with this in mind, I'll go back into index.js, and now I need to start configuring out my database client. So I'm going to go ahead and create a function called dbClient. And what we really want to do is we want to return, for the moment, just the database URL itself from the process. So I'll go ahead and return that. And so now what we want is our DB client is basically equal to that. So const, let's go ahead and call this our DB, is equal to that database client. That's roughly speaking where we're going with this. So to actually make this work, we need to start integrating the Neon database serverless. So this package itself. And so at this point, I already have it installed. And if you don't, just go ahead and run that npm install. Once again, we already have that database URL. We just set that up. Next, we need to use it. So this is how we're going to use it. Don't worry about the actual SQL command that's right here. We're not going to look at that one. Instead, we're going to go ahead and use these two items right here. So let's paste this into index.js. And before we go any further, I'm going to go ahead and use this down in the DB client instead. So that's really what I want to return, is that SQL command from Neon. And that's the point of having that. So this DB client, then I can run different commands directly from it itself. So we could do something like const results equals to DB with these backticks. It's really cool that you can use these backticks. And you can do select and now, just like we've seen before, this should give us some sort of result that we could then pass in to our API request. Okay, so one thing that's important to note is this right here. Let's go ahead and actually try and run this. If you recall, we have npm run dev inside of our package.json to go with our serverless offline, specifically with the stage of dev, which is why I put it into env.dev. So let's go ahead and run that again. And so what we'll get when we actually go to the endpoint of localhost 3000 is we cannot use an import statement outside of a module. So by default, we do not have a standard module. We have common.js. So it's just a slight difference, which means that we just need to change this from importing to being a constant and using require. And if you wanted to convert it to a module, you could, but that takes extra configuration that we're just not going to cover at this time. Instead, we're going to go ahead and use the common.js, which is what is traditionally been used by Expressjs in a lot of these Node.js applications. But now that we've got that, we should be able to use this just fine. So I'll go ahead and refresh in here, and now I get something. It's not necessarily exactly what I wanted, but it is something. Now, why is it not actually giving me what I want to see? This is because we need this to be all asynchronous. So the database client itself, we want to change this to being async, which means that down here, we need to change our callback handler for the route itself. That also needs to be in async, right? So if you think of how any given route works inside of Expressjs, it is also a function. So we can say like our index route, and by default, it comes in with the request, the response, next, and this function itself could then handle all of the things from that function. It could go like this and like that, right? So we can absolutely separate these things out like this. That's just not a common pattern to use with the Node.js application itself. You usually just put the callback right in there. And so putting async in front of it is the same thing as putting async in front of a normal function itself. Now, if you didn't know that, that's what's going on. Because now that it's asynchronous, we can now await our database client. And then within our database client, to actually use it, we can await it as well. And to really follow a little bit closer to the convention, you could also just call this SQL as well. And so that kind of fits a little bit more with what you'll see throughout the documentation on the SQL client itself directly from the Neon database serverless, which is what we do see in the docs itself. That's this right here. So as you can see, it says await. And that's how we're actually able to do that, is by making everything asynchronous. And so now we should actually see some sort of result that goes into the actual database itself. So back into our local host, we rerun this, and we should see something that is coming from our database. Now, the first time we run it, it might take a moment because our actual database on the Neon console has to be active for it to work. And so that first little bit of latency does make a difference. Now, I'm also using a database that's in US East. It's quite literally on the other side of the country than me. So how fast it's gone is really, really great. So the speed should improve quite a bit when I actually deploy this application into AWS Lambda. And so what we've got here is results that actually is an array here with some data. And that's just what happens from this particular command. So we can actually unpack the results like this. If I refresh that, that should give me a dictionary value. I might need to refresh the server itself. Or what we could do in here, let's go ahead and run that again. Refresh in here. Now it's a dictionary value. Now I can actually just do results.now. And we might have to refresh the server once again. So let's go ahead and try that out. And I refresh, and there are my results. This is now a timestamp that's coming directly from the database, like we saw when we were in the SQL editor itself, and we ran, select now, just like that. It's the exact same command going to the exact same database and returning roughly the same value. Of course, it's changing just for however long I need to actually look at this. So yeah, now we are fully integrated with our Neon database inside of our Node.js application. So that means we can start doing a lot of more interesting things. Before we do that, I want to point out this right here is raw SQL. So this command, what you can do with await SQL now is you could write out your own raw SQL. So if you wanted to experiment with how you know SQL itself, you could create an endpoint that would, in theory, accept data to run various SQL commands. In other words, you could create an endpoint that handles a form very similar to what we see inside of the console itself. That's not something I'm going to do. I want to make sure that the commands I am running are exactly to the structure that I want them to be. I don't want to have pure SQL commands running through in my application. At least that's not how I want to design this one, right? So now that we've got this all integrated, there is one more thing that I want to add in to the configuration for Neon. And this just has to do with the connection itself when we go into our deployed serverless environment. I want to just change the configuration to use an experimental feature called fetch connections cache. And we're going to set that being equal to true. This is for HTTP connections and non-pooling. Right, that's really what's going on here. Feel free to look at the documentation themselves, but we're not going to have pooling in a serverless environment because that server is going to be scaled down. So it's a little bit more difficult to pool connections when they aren't persistent. It's going to cause a lot of havoc and issues. So that's why we're going to be using HTTP connections, and that's also why I put that configuration, just to make sure that that's in there well before we actually go into production itself. Pretty great. Now we're going to do our first deployment of our Node.js application, of course, using the serverless framework to make sure that it runs into AWS Lambda. Now, to make this work, I'm going to go ahead and use this command serverless, but instead of saying serverless offline, I want to do something different. So we'll give it a new script name of deploy, and then we'll go ahead and use serverless deploy, and then the stage we want to deploy. And of course, that stage is going to work very similar to the offline, where it has maybe its own environment variable. So let's actually change the stage to simply prod. And so now to run this, I'm going to go ahead and run npm run deploy. And of course, it's going to run this command in here. One of the big benefits of writing the script in here like this is that you don't have to remember what different flags you're going to be adding for different deployment options. In this case, the stage of prod will always be the stage whenever I run npm run deploy. And so what we've got here is we've got loading environment variables from .env. So it's going to look into the .env here, and then it would look into .dev if that was the stage. So if we wanted to add in our .prod stage, we could do that just like that. And so now let's go ahead and add in just another key in here. So hello world equaling to this. Something like that. We go ahead and run the deploy again, and we can see the different environment variables that are coming through in here. And so, of course, it fails to deploy it for a number of reasons. One of them, the security token is invalid. So at this point, I have credentials on my local machine, but they're not the valid ones. And so I also have this US East 1 in here. So two kind of major issues that we want to address. We want to verify that this is the correct region. And in package.json, I can actually bring in that flag of region. And in this case, I'll leave it in as US East 1. Now, the question, of course, is going to be, how do we know which region we want to use? Well, it has everything to do with our database. We want to make sure that the region is as close as it can possibly be. And so to do that, we can use Neon CTL, and we can go ahead and do projects list, and we can see the project that we're using and the region ID, which is US East 2. We can ignore AWS dash because US East 2 is the AWS region itself. So we can update this region to being that region itself. And then we can run deploy again. And this time it's going to attempt to do it in the correct region, which is exactly what we were hoping for. So the security credentials we need to address. But before we do that, I want to bring your attention to something important and interesting. So yes, it is deploying using this .env.prod, right? So it's going to use all of these environment variables, and it's going to build something and go and do what exactly? Well, what is happening is it's building this .serverless folder inside of our local repo. So it builds this folder out and then creates this zip file here. So what we could do is we could actually unzip this zip file, and we could take a look at what happens. So inside of my project here, I can actually see, what do you know? It's actually everything related to my repo. My main code itself is zipped up and brought into here. It's actually missing the .env files, though. It doesn't actually have those things in there, which is pretty nice and fairly important, right? And it also doesn't have the .getignore, so it is missing some things, but it does have all of the node modules in there. So it's kind of like a point-in-time instance of the application itself. But it's also showing me something in this state file, and that is all of my environment variables. Now, on one hand, this is great. It actually uses my .env.prod, and it's just going to go ahead and do that, and I can just deploy this application, and in theory, this will just run, which is nice. But the thing is, this state file is, well, it has our database URL directly in the state file. So this is a security concern for sure, because we will show you where this is going to end up in just a moment. So to make it end up where it needs to, we need to actually update our credentials. So if you've used the AWS CLI before, you'll know that most of the time you'll log in there and it'll create something inside of .aws credentials in your application, and you'll see something like this. Now, these credentials in my case are no longer valid in general, but they're also not valid to actually do the deployment. They're not valid to actually use serverless. Serverless itself needs its own policies and its own credentials to be able to deploy everything. Well, maybe it doesn't need its own credentials, but ideally with each project, you attach different policies and then create credentials for them. Now, if you're not familiar with this process, I'm definitely going to show you. But before I show you, I want to just show you this reference that we have here for this IAM policy. So this is a policy we're going to be using for the serverless framework. It's pretty extensive. One of the things that's important is when you actually use this policy, you want to change the AWS ID to the correct one for your account, which is something we will do in just a moment. But the idea is once you actually have the permissions in place, then in your .env, for example, you'll have something called AWS access key ID, and then AWS secret access key. Cool. So we need to set these up. Let's go ahead and create these now. To do this, I'm going to go into IAM, and I'm going to create a user group. This group, I'm going to just call it Serverless Framework. Okay, just naming it Serverless Framework, and then we'll go ahead and create this group. Next, I'm going to go ahead and create a user, and I'll go ahead and create this user as Serverless Framework User. Realistically, I would actually probably want to give it the name of my project, so Serverless Node.js API, just like that. We do not need to give them access to the management console, but what we do need to give them access to is the permissions that we'll add to this group. So I'm going to go ahead and add into the serverless framework. I'm going to add this user into that group. Next, what I want to do is we can review and create this user. So let's go ahead and create them. So all I did there was create a new user and add it to the group that I just created. At this point, they have no permissions, and they also don't have any security credentials. So going back into our user, we'll go into security credentials, and we'll go ahead and create a brand new access key. Go ahead and create this key. We'll hit other, and then I'll go ahead and say next. And this is going to be our We don't actually need a description tag it unless you really want to. Here are those access keys. I'm going to go ahead and copy this one. The first one is the access key ID. The next one is the secret, and we'll paste that in there. The names of these have to be exactly this. The actual keys are going to be different, of course, but the actual AWS access key ID, it has to be in this format. It has to be written just like this. Now, you could use it inside of credentials as well, but the reason I'm using it into .env is so it doesn't conflict with my system at large. And so I want to, once again, run my npm run deploy and hit enter. So this time what it's going to do is it's going to attempt to use these environment variables credentials. But one of the problems is it's actually loading these into my environment as well. This is definitely going to be causing an issue very, very soon. But now our new error is a little bit different, and it says that it's not authorized to perform this data. So the user I just created is right here. So that is the user we want to give permission to be able to perform all of the things that serverless wants to do. And the reason this is working is because it's in the .env itself, this right here. So now we need to give those permissions. We actually need to create that policy. So again, in the actual GitHub repo itself, you can go through and see this exact same policy. I'm going to go ahead and copy it. The repo is right here, and it will be linked in the description as well. And so in my case, I'll go ahead and create this policy reference, and it's policy.json. I'm going to paste it in here. And I'm actually going to add this to gitignore because I do not need to commit this. So I'll add it to gitignore. And what we want to do is we want to change this AWS ID here. So I'll do a Command F or Control F, and we want to do a find and replace, and I'll do a colon in front and back of it. So we want to change that all across the board. And the way we're going to do that is by finding the actual AWS ID for our account inside of IAM. So if I go ahead and close this out for the user, go into the IAM dashboard, we can see the account ID right here. I'll go ahead and copy that, and then we'll go ahead and replace it inside of this policy. And we'll just do replace all, just to make sure that our account ID is in here. Now, you could, in theory, use just a star here, but I like narrowing this down to specifically the account in the case of this particular policy, so that if I were to reuse it again in the future, I actually review it before I use it. And that's the idea. Okay. So I will say that the permissions themselves, if you were wanting to remove permissions, you totally could, but that might cause problems when it comes to the serverless framework itself that you'd have to look into even more. But now that we've got this policy, let's go ahead and create it by going back into the IAM, into policies here, create policy, and I'm going to go ahead and click on the JSON, and we'll go ahead and paste this in. And so now I've got that policy in there with, I think, everything that we'll need. I did test this a number of times, so let's go ahead and create this policy now, and I'll just call this one the serverless framework permissions policy. And then notice that it has very limited access. I'll go ahead and create this policy, and we want to attach this to either our user or our group. I'll go ahead and attach it to the group. Click on the group itself, click on permissions, click on add permissions, attach policies, and do a quick search for the policy we made. So the serverless framework policy, I'll go ahead and attach that. Now, the important thing about using permissions and policies within AWS is you can attach too much permission, right? So the admin access gives quite literally all access to all AWS services, which could get you into trouble. You could accidentally provision way too many things and cause a lot of havoc within your account and charges as well. And of course, that also means that you maybe accidentally expose your access keys and all that. So the policy we're using is really limited to what the serverless framework needs to do. It doesn't have unlimited policies, just a few, which is why we created our own, and it's why it's working in this way. So at this point, we now have all the policies in place to run what we need to run within our serverless framework. But before we do, I will say the policy itself, if for some reason the policy is not working, we have inside of the gist itself for the policy reference, we do have a gist available for you that will have the latest up-to-date information related to this policy and the serverless framework. So be sure to check that out. That's going to be linked in a lot of different places. But the idea being that the policy we use needs to actually work for everything we're trying to do here. So with that out of the way, let's go ahead and actually run our deployment here. Right? So we'll go ahead and do npm run deploy, hit enter. And so this will attempt to deploy this now with all those policies in place. And so since it's going to deploy or attempt to, I'm also going to go ahead and create another script in here, and we're going to call this remove. So deploying and removing are basically the two sides of the same coin. It's really just that simple to deploy it and then turn around and remove it. I'm going to let this finish. It might take a minute or a little bit more depending on our speed and everything that's going on in the AWS configuration. But I'll go ahead and let this finish, and then we'll come back and actually test out that deployment. It's not quite done yet, but it did say just a moment ago that it was uploading to S3. So since that just finished, I want to actually look at S3 to see what that means exactly. So if I do a quick search in here for S3 inside of AWS, we go click on S3. And then in here, the buckets themselves, I want to search for serverless. And what we see here is our serverless application right there. So this is going to be auto-generated for us. That's what the serverless framework does. It will auto-generate these buckets for us. Yes, we could designate our own buckets, but that configuration is a number of steps that we're just not going to cover. So the idea here is we can click on this bucket, we can click on serverless, we can look at our project, the stage that we're deploying, the actual commit of this stage, and then all of that same sort of data, the JSON state and all this. So if I click on this state, once again, if I go ahead and open this, I will see that there's my database URL. And I also have my AWS access keys in here. That's not great either. So all of these things we definitely want to move towards getting rid of. And so we actually might have an error in our deployment because of our AWS access keys. And sure enough, by the time I said that, we do. So we definitely do not want to have these access keys inside of our deployment. Now I wanted to show you this error because it's related to our .env. So we're kind of at this weird spot. It's like, well, I need to use these keys, but I also don't want to deploy them. So how do I actually handle that? Well, luckily for us, serverless.yaml has the ability to do this. So what we can do is we can actually customize what environment variables will be submitted to our backend. So if we do custom and then .env and then exclude, we can actually put a list of environment variables that we don't want. So like the AWS access key here and the secret key here. We can do all of that. And it's really just that simple. Every once in a while, we might have to use something like this AWS session token. And we also will get to a point where we want to remove the database URL. We're not quite there yet, but we will have that for now. So with this in mind, I have some changes that I made. I'm going to go ahead and run this deploy again. Notice that these are still coming up. So it looks like maybe I did something wrong, and this should say exclude. So I canceled that out, and we'll run it again. Now those environment variables are gone, the ones that we just simply don't want anymore. Great. So this is exactly what we want. So once again, it's uploading, and we can see once it's done that progress. So we go into prod here. It's going to show us a new folder based off of that, and it's also based off of the time itself. So this one looks to be a little bit later, so I'd imagine this is the more recent one. And sure enough, it's already uploaded. I can verify the state once again, open this up, and once again, the things that I'm okay with exposing for now are exposed, and the other ones are not. And so once this actually finishes, we will actually test out this Lambda function, and we can also review the function itself inside of Lambda, which is something I'll leave for you to just explore on your own. But for now, I'll wait for this to finish. And there it is. It's fully deployed. So if I go to this URL here, let's open it up in the web browser just to make it a little bit easier to see. It might take a moment to spin up, but once it does, it's going to be really, really fast, as we see here. So there it is. And of course, we can also curl this out and get the same results from it. It has the timestamp that's coming directly from the database itself, which is what this is, right? And it also is using the environment variable for that database URL, which of course is not as secure as we want. So what we need to do is move this towards being a lot more secure than it currently is. And that's definitely something we will do in the next part. But overall, what we see here is we removed our .env variables. We can deploy really simply using basically the same things we've been doing with the offline. Then our policy, this is the part that's going to be the trickiest to get configured and set up and working correctly. If at any point you need to change things and you need to test what policy problems are happening, you can always go into IAM and go into the policy directly. And let's go ahead and search for it. Serverless, click on this. since we have JSON in here now, if I go to edit this, I can navigate to any block section. So let's say, for instance, our S3 isn't working correctly, like this put bucket tagging. Let's say, for instance, that wasn't on there and it showed you there was some issue with that. What you could do is go into that one single block. Notice that over here it says edit statement. Now I can actually look for various statements. So like put tag, or let's go ahead and just type out tag, and we can scroll down here and we can see put job tagging, put bucket tagging, put object tagging. We can just add these things in really simply like that into this one statement, and then it would actually adjust as it needs to. So this is a good way that you could really experiment with what's absolutely necessary when you go through and start building things out. So for example, let's just try this out. I'm going to go ahead and get rid of this describe right here. So I want to just refresh real quick, and I'm going to go ahead and edit out just one single permission so we can see what that error might look like. Right? So we're going to come in here. It looks like I'm still editing. I'm going to go ahead and get rid of this describe star. I'll go ahead and cut that out for the CloudFormation stack itself. We'll hit next, and we'll go ahead and hit save changes. I now removed a pretty major permission. So going back into my local project here, I'll now run npm run remove, which will of course attempt to remove this. And right off the bat, I get not authorized to perform this describe stack resource. So I can't even do anything here as far as deleting it. So that alone will stop it in its tracks for any given user. And so I can actually go ahead and come back and change that once again by going back into CloudFormation and bringing that back in. And that one single permission allows me to do describe, which we can also verify by going into the statement itself. We can go to CloudFormation and describe. As soon as you put describe there, it will describe all of these things. So describe star does all of these actions right here, which is why they're highlighted and selected because of this. If I remove that and come back and type out describe, I can see that none of them are selected. So it's actually kind of nice that I can go about doing that whenever I need to. Okay, so we definitely want to bring that back in. I don't need to do it manually. I'll just write in that one single change, save everything, and now we'll go ahead and attempt to remove this. And it might take a moment for it to be fully propagated as far as the description, but right away, it happens really, really quick, basically. And so getting in the habit of deploying and removing is perfectly okay because our code itself is being tracked by Git, so we don't have to really worry about our code. Our actual database itself is not being managed by serverless at all. The only thing that's being managed by serverless in relation to the database at this time is the database URL. But very soon, that is going to be abstracted away to something a lot more secure. But overall, the idea here is being able to deploy and remove really, really quickly at a moment's notice and having the correct permissions to be able to do that for your AWS user. And so you could also practice right now, just take a pause, practice right now, and actually remove access to this particular user and see if you can recreate access, because it's fairly straightforward. But if you don't know how to do it, then this is a good time to practice that before we move into securing that database URL a little bit more. So let's take a look at that now if you're ready. Now we're going to go ahead and configure our database URL to be more secure by using the AWS Systems Manager. So if you do a quick search for Systems Manager inside of AWS, we're going to go ahead and configure this to work with our application, and more specifically through the parameter store of the AWS Systems Manager. Now, this is not the only place that you can store secrets or variables that you want to encrypt, but it is one of the best ways to do it. So we're going to go ahead and create this parameter here, and we're going to start off with /, I'm going to say project name /stage, and then /var name. Something like that. That's kind of the format, how I think about creating these parameters themselves. So what I'm going to do is, this is going to be called the Serverless and Node.js API. The stage itself will just use prod, and then I'll go ahead and do database URL. That's it. So this path right here is something we will use in the future. So let's go ahead and grab it into index.js. I'm going to go ahead and do const, and this is going to be my database URL, ssm param, and we'll pass that in. Okay, so that's just the name that we'll have. Next up, we need the database URL itself. So I'll go ahead and use the Neon command line tool for the connection string, and we'll go ahead and place that in here. I'll copy that, and we will then place that inside of our parameter itself. So we've got our name, We can use the standard tier. We're going to use a secure string, so it encrypts this data. And then we're going to go ahead and use our current account. We don't need to change any of these things. You can use all of the defaults. The next thing is just going to be the value that we want to encrypt. And then I'm going to go ahead and create this parameter. So it's encrypted at rest. So if I go and look at it, it's going to be stored in here, encrypted until I decrypt it. So this is decrypting it right there. I'm just toggling that value. And then of course, if I go to edit it, I can have it decrypted as well. Okay, so it is stored encrypted. And so what that will allow us to do is, well, a couple things. Number one, we could abstract this to an environment variable now. I'm going to leave it in just as a standard variable, but since you now know how to create environment variables, that would be a good place to potentially put it in your environment, is actually using that database URL SSM param. And it's called SSM. That's just the default name for it for the AWS Systems Manager. That's the name of it, as we'll see when we actually start using the package itself inside of our application. So the main thing here is then I want to actually decrypt this data. I want to be able to look it up and grab it. So before I can look it up and grab it, I want to grab the database URL out of the environment variables. And so inside of my .env, I can leave it there, but inside of the serverless.yaml, I'll go ahead and just add it into exclude, just so it never goes in. And so at this point, I wouldn't have access to my database client at all. And that's what we want to change. So to change it, we're going to be using the AWS client for JavaScript, which is the AWS SDK. And so we want to install this. I'll go ahead and copy the install call here, and then we'll just go ahead and install it onto our project. It's really important that we do have it in our project as a dependency because it is an actual dependency for our runtime. And so the way it works is inside of index.js, we can bring this in, and I'll do const AWS equals to require, and this is going to be the AWS SDK. No surprise there. Then we initialize a SSM connection. So there's going to be SSM equals to AWS.SSM, and then the region itself. So region we will pass in here as well. And once again, I'll go ahead and add another constant in here as AWS region, and we'll go ahead and use US East 2. Once again, you can have this as an environment variable that you might want to change when you need to. The region and the parameter work in tandem together. Okay, so now this is going to get all of the parameters, or at least allow for me to get all of the available parameters inside of that particular region. Right, so the parameter store in that region, it'll show all of them that are in here. This is essentially going to allow me to do that. So the next thing is our actual database URL. So now I'm going to go ahead and say const db URL equals to, well, what exactly? Well, to do this, I'm going to go ahead and bring in the data itself, the data from the param store. So let's just call it param store data. And this is going to be await SSM, the initialized class right here. And we also want this to say a new, because we are creating a new instance of that class. So await SSM.get parameter. And we want to pass in some arguments here. The first argument is going to be the name. This is the name right here. The second argument will be with decryption, and we want to say true. We stored it as a secure string. If it just said string, we would not need to use with decryption. It would just work. Then if I do .promise, I can turn this into an asynchronous call, which is exactly what I want. After I've got that, I can actually use this Neon connection in here with the parameter store data dot, and this is going to be .parameter .value. Just like that. And so this should actually now allow for us to make this work. And so obviously we need to make sure that this is actually working, at least locally, before we even push it into production. Because there is something else we'll have to change with our production environment. So let's go ahead and do npm run dev. And once again, we see that debug is in here. Now that database URL is not in here. And I'm not even using it anyway. So there's nowhere in my application that has that database URL for the client itself. So what I want to do then is open up the local host, and let's just take a look. Let's make sure that I can still connect and still get that data. And sure enough, I am. It's still giving me the exact data that we were expecting from the database itself. In other words, this parameter store data is actually working. So we can console log this out and see that parameter store data as well, just like this. And let's go ahead and just refresh our application. and reload the page, and we refresh in there. There it comes through, and there is that data coming directly from the parameter store. Great. So this same package could be used to set the parameter as well. That might be something we do later, but for now we have the ability to use a production-ready parameter for any given stage. So naturally, we could also come in here and do our constant and say stage, and this is going to be equal to process.env.stage, or just simply prod, right? And so then we would come in here and just change this to being something along those lines. And it should actually be right here. And that will give us at least the ability to modify the stage. Once again, this could be just its own environment variable itself. So now that we've got this, what I need to do is I need to prepare this whole thing for production to be able to just use this. So one of the things about AWS services is they can communicate with other services without a secret key or an access key. They can just do it together. And so in our local environment, we have those keys in .env. Now, the only reason I can actually communicate to SSM with these environment variables has to do with what we did in the last part, which was in the IAM. So if we go into the IAM and into our user groups, into our particular policy that we've got on here, we can see something important to understand why this user can actually access that data. And it has to do with this right here, SSM and star. Now, generally speaking, you probably don't want to give every resource every access to this parameter store. I did this as a quick and easy way to have access locally. Yes, it would be something I would want you to change as well, but I knew I was going to point it out, so here it is. I'm pointing it out, and this is where we'd want to change it right here and now, so that any different project just doesn't have access to all of your parameters on your entire application. But the thing is, when we deploy this to Lambda, it doesn't have permission. It won't necessarily have default permission in here just like this. So we need to actually add in the permission that it needs. We need to give it the permission. Now, one of the ways to do that is by inside of serverless.yaml. What we could do is inside of this provider here, we can add in additional permission. And the way we do that is by creating IAM, and then we're going to create a new role. This role will give it a specific name that starts with serverless. I'll show you why in a moment as well. And I'll give this serverless SSM role. And then the statements we need for this is effect. And we want to allow resource. And we're going to go ahead and say all. And then I'll go ahead and write out all of the things, all the actions I want to allow. And so I'll just copy and paste them, and we'll talk about them right now and where you can diagnose these things. SSM get parameter, what do you know? We just did get parameter. Get parameters, well, that would be multiple parameters by path and so on, right? So these aren't all of the permissions that we would necessarily need, but it is also opening up the resource everywhere. So this role will play the same exact role as this effect right here. And so if we wanted to get more specific with that, we can go into edit here, into our policy or any policy. This is how we can start learning about those various permissions like we've talked about before. We've got SSM here, which is this systems manager. If I get rid of this all, let's get rid of that all call right there and just search for systems manager. Oops, get rid of that comma too. And then look for systems manager as far as the service is concerned. We can start seeing all of the various commands that we can use in here. And this, of course, is going to correspond to the SDK itself, how the SDK can be used. So each one of these policies is important. So get param, we see that there. What if we do create? And we've got a bunch of different create in here, right? Create resource, right? Well, we also might want put param right there. That would be adding one, right? And then maybe delete. And so all of these different parameters that you might want to have for a resource is, well, this is where you'd find them. This is the easiest way to find them, in my opinion. Now, of course, we could just do all of them here, but our Lambda role certainly does not need all of that data. The actual serverless role is mostly just for our user. So going back to these serverless permissions, I'm going to go ahead and abort all of the saves and changes. These permissions right here have nothing to do with our Lambda project itself, right? That's what this role does. The only way it has something to do with that Lambda project is so that my local environment, or really this particular user, right here has access to do what it needs to do. So these keys, these access keys and secret keys, are not on the AWS Lambda by default, which means that this code would not be able to work unless, of course, I were to add that actual role on here. And the reason we have this serverless dash role on here is so that we can actually manage this. So inside of our JSON data, inside of our policy here, if we scroll down a bit and look for our role, let's do a quick command and we look down a little bit for IAM, and we will be able to see that we've got some roles here. So create role, put role, and so on. Notice the name of it, right? So we've got serverless dash is how it starts, which is exactly why I call this serverless dash, and then the SSM role, right? Or I could actually say, to be even more safe, I could say my SSM role or project SSM role, if it does conflict with anything else that the serverless framework gives us. But the idea is if I went in here and called it my SSM role like that, I would have to update this policy for this particular user to adjust for that. Like it wouldn't be able to create it. This is only able to create if the actual name of it starts with serverless. Great. So now that we've got this, let's go ahead and try and deploy this here. So we'll go ahead and do npm run deploy. And what we should see is 2 environment variables working. That's great. I don't have any errors so far about the role itself, but the main thing that we want to verify is the fact that the application, once it's all said and done, is going to go based off of this database parameter that will end up coming through. So I'll let this finish and then we'll check that out. And so now I get this error of IAM tag role action. I don't have the ability to tag this role, so it's not performed the tag role. So this actually gives us the opportunity to see how we can adjust our policy to make that work. So back into our serverless framework permissions policy, we're going to go ahead and edit it. I'm going to navigate down all the way to the IAM stuff. And so what we've got here is get role, create role, and so on. So in here, I'll select it. We'll do the included service, and we'll go ahead and look for the put, and I think it was tag role. So we'll go ahead and do tag role. And there is the tag role and untag role. So I now add both of those just so I have the ability to do that tagging. And so we'll once again save this. So we'll hit next here and save changes. And then of course, now I'll go ahead and run that deploy once again. And of course, that's how it goes. This is how I was able to build out that policy in general. And these things modify every once in a while. There's little things that the serverless framework adds on that it needs access to do. Like tagging a role, I don't think is so critical that it needs to have it happen. But there's also things behind the scenes that I don't know that's going on that might have a good reason to be able to tag that role or have that particular permission. So yeah, I'll let this finish and then we'll come back. And here we go. We got this success and it was able to deploy. So I'll go ahead and grab the URL itself. We'll just do a quick curl call. It might take a moment for it to boot up completely all across the board, but once it does, it actually gives us the results that we were expecting. So now what I want to do is simulate the problem with something on Lambda itself. Like if there was some issue on Lambda, let me just go ahead and use UR. I'm just getting rid of the L there altogether, right? And the only reason for that is just to see what's going to happen with these results here. And I also want to bring in something else, and that is I'm going to grab this right here. I'm going to just go ahead and say now, and then I want to go ahead and declare a delta, and this is going to be equal to date.now minus now.now.getTime. And then we're going to divide this by 1,000. I want to see how long it takes for the application, which is what this will do, to actually reach the database and come back. And that's what's going to happen with this new delta here, just so I can see what exactly is happening within the database. So we can, once we actually get everything working, we will see a delta. So it'll be something that changed at least a little bit. And so this is going to be our now.now or maybe our db now result. Let's just make it a little bit more verbose so it's not too confusing here. And there we go. Okay, so now that we've got this, let's go ahead and do another deploy. So I don't need to push it or anything like that. I just run npm run deploy and it will start that process. So what's going to happen is it's going to fail, right? So it's not going to find the parameter and it's going to be a major system error. So what we're going to need to do is look for AWS Lambda, we'll actually go into Lambda itself. We don't need to type out AWS actually. So we'll go into Lambda itself. We'll click on here, and we will see very soon where we will be able to navigate the problem with this. And it comes into Monitor, this tab right here. We can go to View CloudWatch Logs, and this will allow us to see some of the errors that might come through for this particular project from these log streams. And we can see other logs as well, like the things actually working. But the idea is this log stream is how you might be able to diagnose errors with your particular project. So in my case, that error is going to be this parameter is invalid. And so the application itself won't attempt to use that parameter until it attempts to use the database client, at least at this point, right? So realistically, I think when I wanted to boot up the application, I might then want to initialize the database client right away instead of always in the endpoint itself. But those are optimizations that I don't really need to worry about because they're not really that necessary at this point. But the idea being that we've got an error coming through, and I just want to see if it's done. And here we go. We've got it done. I'll go ahead and do a curl here. And we should get an error back, invalid or internal server error. So let's go back into our production, and we've got 2 new streams here. I'll go to the newest one, click on that, and we're going to see that we've got a runtime error right here, and then we'll go parameter not found, right? So that's the actual error itself, and this obviously means that a parameter name was not found. I don't see anything else in here for catching the error or handling the error, as in right here, we might want to handle that error. Or down here, we might want to handle that error in the actual application itself. But I wanted to simulate what would happen if there were an error with the parameters themselves so we could actually update it and make sure that it's working correctly on our next deploy, right? And so this would be something you'd also want to test locally and make sure that all of that stuff's working. But it is important to be able to also see the logs when you need to inside of a Lambda function. And just a quick recap as to how to get there. You go to the Lambda function, you go to Monitor, and you go to View CloudWatch Logs, and then you'd be able to see all of the various logs in there, including the metrics that are happening for the application itself and how quickly all of that's working. And so once this actually finishes, I do want to see that updated delta. I want to see what that value is because it's pretty impressive. So while that's still building, I'm going to go ahead and create a new, we'll do npm run dev. And then I'll go ahead and go back up. I want to compare and contrast the production version versus the local one. So if I do curl http://localhost 3000, I should get that delta, and it gives me a pretty fast delta. Right? This is local, and then if I go into production, do the same thing, and it will take a moment to boot. So the first one might be a little bit longer, but then it's going to be just as fast or a lot faster. It really depends on where you are located in the world and how quickly the delta ends up working as well. But overall, that's it. We are able to now check is how fast we can actually get the database call back to us, a return call back to us, have the database spun up, and then also have our application now live and out there so we can use it in many different ways, which is great. So from here on out, we just need to build on top of this because realistically, we have the foundation we would need to build full-fledged applications. We've got our database, we've got a way to deploy it, and we've got a way to secure it with the secure data itself. It's fantastic. Now, one of the things that we're not going to cover are custom domain names. So adding a custom domain name to this system. It's not natively supported by Serverless because there's a lot of different ways to put custom domain names on AWS Lambda. There are some support out there for custom domain names, but that's just not something we're going to cover at this time. That would be the only thing I would want to improve about this project for fully production consumer-facing projects. If it's not consumer-facing projects, which is kind of what we're assuming, this could go anywhere now. We could actually use it anywhere just by using that endpoint itself and then making updates as we see fit. Now we're going to go ahead and decouple our application so it's a little bit more concise on how it works and it's just cleaned up. Then we're also going to update our AWS SDK. We want to upgrade it to a newer version. Now this older version is still valid and it still works and it'll probably work for years to come. But overall, we want to start adopting the newer stuff because the package itself is probably smaller as well. And maybe just a little bit easier to use than what we've got here with this .promise and all that. That's kind of a mess. So let's go ahead and use the new package, which is AWS-SDK/client SSM. So we'll go ahead and install this into our package. since we're installing that, I'll go ahead and do npm uninstall the AWS SDK. I want to get rid of that one right away just to make sure I don't have that any longer. So with this in mind, I want to just change how I'm going to grab that parameter itself. So to do this, I'm going to go ahead and create a new module with lib/secrets.js. And I'm going to quite literally copy everything from this DB client stuff up. And so this is where we'll change everything. So I'm going to get rid of all of the Expressjs things that we just simply don't need in here. And this will just be get database URL now. And it's going to be roughly the same values here. I do not need the Neon stuff just yet. We will decouple that one as well. But overall, if I were to keep the old version, this is how I would decouple it, right? Just like that. And then I would update where I need to use this database URL with the imports, as we'll see in a little bit as well. Okay, so with these things in mind, I want to go ahead and use that new SDK. So what we could do is we can look in the documentation and scroll down a bit. You can see the installation process. We've already done that. You can also see the import process is basically this right here. So I'm going to go ahead and copy this, and we'll go ahead and paste this up here now. And so I'm going to get rid of this AWS here. And to create the client, we'll go ahead and come down here and say const client equals to, well, let's see how they do it. In the documentation, it says new and SSM client. Hey, what do you know? It's very similar to what we saw before. In fact, we can pass the region in like we saw before as well, the exact same way. So that modification was already really simple. So we can get rid of that. And it's not a whole lot different going throughout. So the next one is going to be the actual param data. So I'll leave that in, but I'll get rid of this get SSM parameter away, but rather just turn this into an object itself. Then we need to actually create this as a command. So we'll say const command, and this is going to be equal to, well, what we see in the documentation is this list associations command, which is not what we want. We want something different. And there are a lot of different commands that you can run in here. If you scroll down, you will see all of them. The one we need is, of course, the get param command. So get parameters is in here. So let's go ahead and grab that, and I'll just search by it. Unfortunately, it doesn't give me the actual command that I want by searching in here. If you go into the API reference, you will see it. But what I know is I can just go ahead and change this to just get parameter command. It's really just that simple. So the command itself will then be new of that command with these arguments in here. And then we want to grab the result from it with await, and this is going to be client.send and that command. And then the final data is just simply that result parameter.value. And that's it. Just a small modification to how this ends up working. And then we'll go ahead and do module.exports, and the get database URL is equal to that right there. Great. So what we could do now, of course, is change our DB client to work off these secrets. Now I could do it in the index.js, or I can follow along this pattern of decoupling and decouple the DB client to its own location. So that's what I'll do. I'll do db/clients. I'll use the S in here for a reason, as you'll see once we get to the Drizzle stuff. Now I'll go ahead and copy all this once again, just because it's already working mostly. Okay, and I'll get rid of the things I don't need, which is serverless, HTTP, and Express. I also won't need this AWS part here. Instead, what I'll do is right under the Neon imports, I'll go ahead and do const secrets equals to require, and then my new library for secrets. And that's the one I'll use. So I'll go ahead and get rid of all of the SSM stuff in here now. And so really, this param data store is no longer going to be that. Instead, we'll get rid of all these comments even. I'll just do const db URL equals to secrets.get database URL. And of course, this is an asynchronous function, so we'll go ahead and do await those secrets. And now I can actually just use that database URL just like that. So it's cleaned up a lot in both places, if you ask me. The database URL SSM param I might put in here, or maybe I have it in as an argument itself if I needed to change it and support other things. But overall, it's definitely cleaned up a bit. So the last thing, of course, is just to bring in our database client into the index itself. So to do that, we'll do module exports, and the database client is going to be that database client. Let's go ahead and stick with that same naming convention we just did with the get database URL to get DB client, and just change it ever so slightly. And now in index.js here, all we need to do is bring that one in as well. This time I'll just go ahead and import the function itself. And so we'll do const get db client, and this is going to be require, and then ./db and clients, just like that. And of course, the index file itself is not inside of any given folder, which is why we can just do that. So now that we've got that, here is the old DB client, which I'll go ahead and get rid of. And now SQL itself can be just await get DB client right there. And I can get rid of all of the old AWS client stuff, as well as Neon, right inside of this index.js, because now it's imported in places that it makes a lot more sense. So of course, the last thing to test here is that this is actually working. So let's go ahead and do npm run dev here. And so there is my dev server running. And let's just do a quick curl call. And we'll go ahead and do curl. And after a moment or two, because everything needs to spin up, it does that exact call. Great. So there's one last thing that I want to fix, and that is this delta here. This delta I don't think is actually accurate. So what we want here is we want to grab now, which is going to be date now. We want to actually call this before we call our SQL command. This will now be in the past, where this should be in the present, hopefully. We're going to go ahead and change the ordering of this just slightly. And I'll go ahead and get rid of the divided by 1,000 here. We'll save that. And I want to just refresh real quick and run this and just see how quickly I can grab this data. Okay, so let's take a look at the delta now. It should be a different number. So this is still in milliseconds, so we can put that back of /1000 just to make it a little bit more accurate as to seconds. But overall, we just wanted to see something a little bit closer to how long it actually takes. So I'm making this request from the other side of the world, and it actually is still going pretty fast, which is pretty nice. But with this in mind, we're going to go ahead and do npm run deploy. I did say the other side of the world. I meant the other side of the country. That's all. So I'm going to go ahead and deploy it, let that run. There's one more thing that I might want to have in my scripts in here, which is just going to be simply info. So every once in a while, when you run deploy, it's not necessarily going to always show the endpoint that you are using. So using just info will give us that endpoint. So we can see that by running it in here with npm run info. This will give us that data from the current one that's being deployed, which is going to be this endpoint, right? And so the endpoint will or could change if you took it down and then brought it back up. That endpoint will most likely be different. But I'm going to let this finish, and then we'll just verify everything is working with our stuff decoupled and all that. Looks like it finished. It was pretty fast this time, so we'll go ahead and curl it out, and I'll run that, and there we go. So the delta is really, really small, right? That's the point of what we see there. And so the actual commands themselves, the timestamp, it's a little bit tricky to get an accurate representation of the timestamp that's happening. But overall, we do see that the actual delta is not really that different. It's like almost instantaneous because of how close it is. Whereas when it was on my machine, it was a little bit longer. And that would make sense because of how far away it is. But it is very fast. Cool. So now that we've got this decoupled and we're using the new AWS client, it's time to actually start building out our schemas so we can actually get to the process of actually putting stuff in to our database. Now we're going to go ahead and implement the Drizzle ORM. Now ORMs are great because they allow us to basically use our runtime language to manage our database. In this case, our runtime language is JavaScript, and it's going to be managing our Postgres database. And Drizzle ORM is going to handle that interaction for us. So we can just write a bunch of JavaScript instead of writing a bunch of SQL. And what it's going to do is it's going to allow us to insert data like you would with SQL. It's going to allow us to retrieve data, delete data, anything you would need to query it. But it also treats the data with the same data type. In other words, if in the database it's an integer, JavaScript's also going to treat it as an integer. This is also true with timestamps, and we've already seen that. So using just the Neon database client, we actually saw this select now doesn't come back as a string. It comes back as a date object itself, which is how we're just able to do this. In other words, I don't have to parse it. I don't have to like parse the date from here and build out some complicated parsers just to use the value from the database itself. And that's the key here, is we want to make it so it's super easy to use values directly from the database without making any major changes. So let's go ahead and create our first schema. So inside of DB here, we'll go ahead and do schema.js, or let's call it schemas actually. So schemas.js is where we'll define our tables. So this is what we're going to do is we're going to do const lead table. And for now, I'm going to go ahead and just put a dictionary here and really think out what I want in a lead table. Well, I'm going to go ahead and say I want an email. Perhaps I want to have a timestamp, right? Like a created timestamp. And maybe I want a description, maybe a source, right? Maybe the first name, maybe last name, right? And so these are all of the columns that I might want to store in my database. Now, to keep things simple, I'm just going to go ahead and just do email and timestamp for now. But instead of calling it timestamp, I'll just call it created at. So these are going to be the fields we will want to use. And so we need to actually design these in a way that makes sense within the Drizzle way of doing things. So let's go ahead and comment it out for a moment. And let's take a look at the Drizzle documentation and how this is done. So inside of Drizzle's, at orm.drizzle.team, in the docs, if you scroll down here, we've got these column types here for managing the schema. This is where I like to start because, well, I want this to manage my database. So we need to start with designing the tables we're going to design. And of course, you could reverse engineer this too if there were already existing tables, but that's outside of the scope of what I want to accomplish. Instead, we want to just create the ones that we want to create. So in here, we're going to go ahead and look for a column type called email. And we're going to be severely disappointed. There is no column type email. Now, this is for good reason. That's because email is really just a string of data, right? It's just like abc@abc.com. That's just data. That's just a string of data. So validating that it's email is going to be something we'll do later. For now, we just need to treat it as if it was data. And that is going to be text, right? So it's really just text itself. So we're going to go ahead and follow this line of thinking right now to build out our lead table. So I'll go ahead and copy and paste it in. And we can't do it in this fashion. Instead, we have to change it to const and then equals to require. And that's how we actually do our imports with this ES5 or the common.js module. And so the next thing is going to be our table. So the const table, the actual variable name itself, or the constant name in this case, we actually want to keep it in as lead table. The actual database table itself, I'm going to call it leads. So this is going to be my JavaScript name for the table. This is going to be the actual database name for the table. And what do you know? This is also the same. So the first thing is going to be our email. We want to leave it in as email. This is going to be the text data type or the text column. And inside of there, we're going to go ahead and leave the database as email as well. So they are corresponded. They're the same. You don't always have to do that, but that's one way to do it. Next, we're going to go ahead and do our created at. Now, within JavaScript, I typically use this camel casing. I think that's the best practice within JavaScript. But in the database, I might want to change it a little bit differently and use snake case, which is common inside of databases. But you could use camel cases if you want as well. So what I got here is a leads table, but hopefully you have a little bit of a red flag going off or a little bell going off. Is like, should I treat something like created as or created at as text? Well, no, there's another data type and we've already seen it. We've already used it, which is related to a timestamp itself. So going back into our column types, we can scroll down and we can see there's one called timestamp, there's one called time, there's one called date. So I can actually use a timestamp itself. And that's what I want. So I'll go ahead and come in into my schemas and use a timestamp in here. And so I'll go ahead and use that instead. So we can also set a default here as to default now. So default now works on timestamps. It doesn't work everywhere else. So if you wanted to set a default, let's say for instance for a description, let's do that now. We'll just add in that new column. I can add in a default here with just simply default and say this is my comment or something like that, right? We can really build that out on how we want to do it based off of the data tables that we have here. And so another advantage of using specific integer types has to do with doing calculations or running functions inside of the database itself. So if I were to jump back into the Neon console here, I want to show you this in action. So first off, this select here, I can run this and this will give me a bunch of numbers, right? It's going to generate series, it's going to generate numbers from well, in theory, 0 to 100. But it actually goes into 101 rows. So it does from 0 to 100 into however many rows that takes, which is what that generate series does. And now we can also count how many rows there are by selecting and running that. And this is a database function to count up all those rows. We can also use a database function to sum up all of those rows. There's many different functions that you can do, and you can also see how this would affect maybe different rows in there as well. So if you did 100 and you multiply each row by 1.2, that would give us that sum, whatever that ends up being, right? And of course, you could also do much bigger rows as well. So this is where databases start to really outshine doing something directly in JavaScript. You would actually do the calculation, something this big, you would do it on the actual database side, and then you would bring it into JavaScript. And so that's where these data types have yet another reason to use them as the correct data type, right? So in the case of the timestamp, this is great because then I could use the JavaScript stuff to calculate how long it's been, basically, when I want to display it. But also, if I wanted to do like the number, of entries, I could do something like that, and then that way I could then grab maybe an integer type. So we come up here, we've got an integer. I could bring in an integer in here as to what that would end up being, right? And we could have this default being 0. Now, the integer itself, we would also want to import it. Okay, so there's a lot of different ways on how we can think about writing out these actual tables themselves. I'm actually not going to do that number of entries this way because there's a way to count it in the database as well, with the email being the same. So that's outside the scope of this one, but these are generally the fields that I want to have. But there is one more field I want to keep as well, and that's going to be an ID field. So every time I do an entry, I want to have a new ID field in here, and the way we do that is by using something called serial, and we can set this as our primary key, just like this. And this will be our primary key for the database, which helps with indexing and speed and all sorts of stuff. But overall, the primary key here, and we'll go ahead and say not null. In fact, wherever I don't want this to be empty in the database, I will go ahead and say not null. The description itself, it could be empty. That's okay. And so now I've got my actual schema that I want to use for my entire project itself. I've got something, a table with ID, email, description, and so on. So it's time to actually bring this in to our table or our database itself. But the thing is, I don't have a way to bring it in just yet. So let's go ahead and do module.exports and lead table. And so what we've got here now is the starting of creating an actual table in the database, but we don't actually have the SQL behind it. So we need to create the SQL behind it, and then we need to run or migrate that SQL and actually execute that SQL. And so that's what we'll do in the next few. Now we're going to convert this JavaScript schema into an actual SQL migration file. So to do this, I want to start off with creating a folder called migrations. Now I'm putting it inside of the SRC because I really just want this all bundled in one place. Sometimes it's recommended that you just put it in your main project itself. So with it in here, with this folder existing and my schemas existing, I'm going to go ahead and create a new file called drizzle.config.js. So this configuration itself is going to be fairly straightforward. We declare a constant called config, and we set this equal to, well, our schema, the location as to where it is, and then where we want to output this schema, as in that migrations folder. And then we're going to go ahead and export this as a default. So export default and the config itself. So the reason I can do this is because the way I'm going to actually use this file is going to be right inside of package.json. I'm going to go ahead and come below here and do something called generate. And this is where we'll use DrizzleKit itself. So DrizzleKit will allow me to do DrizzleKit generate :PG, as in Postgres, and then config equals to drizzle.config.js, or that file name and that file path. So in this case, the file path for drizzle.config.js is right next to package.json. If you had it into the SRC folder, you would do something like that. Okay, so with this in mind, I now have a way to call this file, but I don't have the configuration correct. So what I'm going to do is I'm going to copy this relative path here, bring it in, and what do you know? Then I'm going to go ahead and copy the relative path to migrations, also bring it in, and there we go. So we can use // if we need to, but the idea being that it's a relative path to wherever Drizzle config is. And once again, if it was in SRC, we would get rid of SRC. No surprise there. Okay, so with this in mind, let's go ahead and run this, npm run generate, and hit enter. And all this is going to do is create our SQL file. This is quite literally the SQL that will run to match this schema right here. And if we were to change anything, let's say, for instance, we got rid of this description here, I want to generate that migration file. And once again, it shows me exactly what I need to run in order for me to match my schema to my database, right? So it's going to do each one of these things. And that's it. That's really just that simple. And if I were to add a whole nother table, let's go ahead and add in a whole nother table. I'll call this lead table 2 and leads 2, whatever, right? Let's go ahead and export it. Just make sure you export it as well. And then I run the schemas again. Now it's going to go ahead and show me, hey, what do you know? It's creating a new table in here. So since I haven't actually touched the database yet, I can actually feel comfortable about deleting this folder. If I try to run it again, it's going to probably give me an error, or it's going to actually do the entire thing itself, right? So the actual migrations folder was created this time, but I've had it where it didn't create. But what we see is it actually will now just combine those two commands into one. And so this is where you can really learn a lot about SQL itself because, well, we're using JavaScript to generate that SQL. So in my case, I want to get rid of all that, and I really just want that one single migration file itself, and that's where we're going to leave it, is just like that. Now, there's one other thing to note is this meta folder in here is giving a snapshot of each change that's happening. So it's really keeping track of the changes between these SQL files themselves. So when we go ahead and run it, that's how it knows not to do anything. It didn't actually change anything because we didn't change anything in our migrations. So that's actually pretty nice that it has a history of these changes. The other thing about this that's really great is I can check this into Git so I can keep those changes throughout and I can see all of the schema changes that might happen. So if at any time I need to roll back those changes, I could. And also I could run these migrations on, well, maybe a branched version of the database and make sure everything's working correctly before I actually run those migrations on the main version of the database, which is yet another thing to think about when it comes to developing with the various schemas and, of course, Drizzle ORM. So at this point, now that we can create or generate our migrations, we actually need to perform those migrations. And to do that, I'm going to make my own CLI tool to actually make that happen, just because it automates it just a little bit to work with our serverless environment that we have, and more specifically with our Neon database and all of our Neon client related things itself. Because as it stands right here, this actually won't do the migrations for us. We need to do a slight variation on this. So let's go ahead and take a look at how to do that now. Now, there's a few ways to perform these migrations. One of them is you could just copy and paste it and just run it wherever you run SQL. Like, for example, in index.js, we could run it like this. We could go into the console, run it there. But those things aren't scalable and they're prone to a lot of errors. Instead, we want to automate them. So to automate them, I'm going to create a new SRC file called CLI/migrator.js. So this right here is going to use TSX to be called. So TSX src CLI migrator.js. So we want to call it this way. And the way it's called is by doing if require.main equals to the module itself. We're going to go ahead and console log run this, exclamation mark. So obviously we need to fill out all of these things, but before I do, I want to make sure that TSX is even working. So inside of my package.json, I want to go ahead and add in to my dev dependencies two things. So npm install -- save dev.env, and then also TSX. So .env is going to play an important role as well, as we'll see in just a moment. But in my migrator here, let's go ahead and just run this. I'll go ahead and use this command itself into package.json. And we're just going to call this migrate. There we go. So npm run migrate. Hit enter and run this. Great. So that's exactly what we wanted to see. The next thing I want to check is the environment variables, access key and secret access key. We just need one of them, really. So in my migrator here, I'll go ahead and do console log and process.env.aws access key. Run it again. Ooh, undefined. Now, this is why we use the .env. So if I just run require and .env, then .config, run that and run it again, now we can see that environment variable, and it's coming directly from .env. So just like with our serverless package, we have .env being able to be used, our now CLI package can also load in those environment variables like that. Now, why is this important? Well, hopefully you realize it's important because, well, we need to grab our secret. We need to get that database URL. And so back into my migrator here, let's go ahead and import that database URL by doing const secrets. And this is going to be equal to require and .. and there's going to be lib secrets. And then now I'll go ahead and do my secret itself. So how am I going to go ahead and call the secret because it's asynchronous? Well, I'm going to go ahead and do async function, and we're going to call this perform migration. And then I'll go ahead and do the const db URL equals to await secrets.get database URL, and then I'll just console log that db URL. Okay, so then in this main module here, I can just do the promise handling, and we'll say val equals to, and something like this, and then catch error, and let's go ahead and console log the error. Okay, and so we can exit the process with process.exit 0. This is successful. We can also do process.1 as in unsuccessful. Okay, so there we go. Now I want to just see this database URL. Let's go ahead and run it again, and our database URL shows up. So this at the very minimum is how I can actually use those environment variables. Now, we might need to change them. We might need to use different ones, but it's just important to realize that if I did actually use my environment variables, let's go ahead and change it just slightly and do export the access key to something like ABC. Now it's in the environment. I'm going to go ahead and comment out this .env here, and I'll go ahead and run this again. And now it just shows me ABC, and I get an error, right? So that is why we actually use this require.env, but it is actually not required. As long as the environment variables are actually in the environment, it will use them. But if they are not in the environment, which in our case they will not be, we will go ahead and add in that. That way we can actually get the correct data itself, which of course caused this error still. So let's go ahead and just refresh that terminal itself and create a new one, and then npm run migrate like that. And there we go. So now we've got that data. Okay, cool. So now we need to build out and use that database URL. And to do this, we need to use a Neon pool or a Postgres pool, but the Neon serverless pool. Now, the idea for this is to have multiple levels of a transaction that might need to happen, which is exactly why we're doing the serverless pool. And so the repo itself for this package actually has some good documentation on how to do exactly what we need, which is doing our pool with a WebSocket itself. So this is what we're going to be doing. I'm going to go ahead and copy all of this, and we're going to bring it on into our code itself for this command line. So the first thing is I need to take out the actual import statements and change them so they are ES5, and we'll do require and like that, and then same with this. And here we go. Great. So let's go ahead and tab this in a little bit. So first and foremost, the connection string, well, what do you know? It's to this database URL. It's no longer process env. It's just to that database URL. Okay. So we would have a console if there's an error with the pool itself. That's something that, well, basically like we would want to just reconnect or try something new. So the next parts of this are how we actually run the query itself. And so the things that are important that we're really going to change is this right here, right? And so that's where we need to actually grab Drizzle and change how we use Drizzle itself. So inside of here is where we're going to run our migration. So at the top, we're going to go ahead and first off do const and Drizzle. and this is going to be require, and it's Drizzle ORM / Neon Serverless. And then I'll go ahead and also, we're going to go ahead and implement this down here. So we'll do const and db equals to await Drizzle of this client and our schema. So we need to also define where our schema is going to be. So let's go ahead and grab the entire module itself. So right above secrets, I'll go ahead and do schema, and this is going to be our db and schemas. Okay, there's our schemas there. Next, what we want to do is bring in migrate. So I'll go ahead and do const migrate, and this is equal to require, and this is Drizzle ORM / Postgres JS / migrator. Okay, so this is a manual way to call migrate. And then the next part is going to just be await and calling migrate on the database itself, and then using the migrations folder, which in our case is in src migrations, right? Right here. So grabbing that relative path, we'll put that in there just like that. So that's it. That's how we will actually run those migrations. At the very end here, we'll await pool.end just to close out that connection after all of that stuff is done. So this is definitely in a lot of different places for the documentation. But the key thing here is that we got our database. And if there's not a database, so we'll go ahead and say if not db URL, then we'll just go ahead and return something along those lines. But now we can actually go ahead and run this migration again. And so let's go ahead and run it. And at this time, what it should do, we should get rid of these console logs. But overall, what it should do is actually update our database. And so we'll see that with, I'll just console log in here, like migrations done. And we'll say running or run migrations, get rid of this, and then migrations error. Great. Okay, so with this in mind, let's go ahead and run it again. No big deal. Running migrations done. Great. So to verify, let's go back into our Neon console, into our tables here, and what we should see is our leads table. Inside of that leads table, if we wanted to look at some of the data about it, we see the different columns and their data types as we see here. Great, fantastic. So let's go ahead and take a look at our actual schemas themselves. Notice the ID is down here as well. Email, created that. Let's go ahead and bring in the description and just do an end-to-end example where we go ahead and run our generate, and then we run our migrate. Okay, and done. Refresh in here. Leads. Look at the description is right there. Great, so now we have a way to change data in our schema, change the design of our schema based off of different columns that we might want to have. Then we have a way to actually migrate that schema. Now, the client, the pool itself, can do a lot of different transactions at once, which is why we use the pool itself. And it does it using WebSockets. So you're not going to do this in a serverless environment. That's why we needed to create a command line interface for it. You would not run these migrations once you deploy it to serverless. You run it beforehand. And so that's even more reason to actually get the production database URL as well, or whatever one you're wanting to deploy to, which could add in some additional arguments that you might want to have for that. Maybe you always have the production database URL as a part of your secrets. So in here, maybe you would want to grab this and go get prod database URL and change this stage in here just to be simply prod. Now, I'm not going to do that. I'm going to leave it as is because that's really the only string that we are using is the production. But you could also change the stage itself in the environment if you wanted to change it to something different, getting that database URL, assuming that it is available. And if it's not, it'll just go ahead and say, it'll return it and not try to migrate anything. So yeah, the pool is great. You can do a lot of big time queries with this pool. If you were not deploying to serverless, this is probably the method you would want to use for your database in general for some of those bigger transactions that might take a little bit longer. So cool. Now that we've got this, we just need to start inserting data into our database using CRUD methods. And then we're going to need to validate that data to make sure it's valid data. But that's really the main things we're going to do as far as the actual schema and database related queries are concerned. With our schema created, our migrations done, we are now ready to start actually creating and retrieving data from our database using Drizzle and Neon. So to do this, we're going to actually implement a curl function. So we'll use curl http:// localhost 3000 and then leads. That will be how we get that data, which in this case it's not found currently. Then we'll go ahead and also use the same exact idea with grabbing post data. So to do post data with curl, we do -x, say post. We're going to go ahead and pass in a header. This particular header is going to be content type of application JSON, which is very common for data that's using an API of some kind. And then we pass in data. In this case, I'm going to go ahead and put single quotes on the outside of it and then double quotes on the inside. So we'll say something like email and test@test.com. And then we'll use our endpoint right there. So those are the two endpoints we need to configure. So the first step of this is to allow our actual data from the Expressjs application to work. So the first one is going to go into index.js. We're going to go ahead and grab this Git path here, and we're going to go ahead and just say leads. So leads, this will allow us to get that data. So if we were to run that curl command after we restart our server here, we can actually see that data come through, or in this case, it's just saying hello world. Now the post data is not any different than this. We're going to go ahead and grab this and just do post. So instead of .git, it's just .post, and that's it. So with that in mind, we can go ahead and curl it again. Actually, we will go ahead and restart the server one time, and then I'll go ahead and press up a few times to that curl post. And once again, it says hello from path. And so both methods are now working, HTTP post and HTTP get. Typically speaking, you use the post method to create data or update it. Sometimes you use a different method than update, but we'll just leave it in as create data. So that's what we want to do here. And the way we actually can create data is, first and foremost, we're going to change the callback handler to asynchronous. And then we're going to go ahead and say that we want to grab the actual data that's coming through from this request itself. So that means we're going to go ahead and say the email data is going to be equal to await request.body. Let's just start with request.body or req.body. So what we want to see here is just echoing back maybe the body data in here, and we'll just go ahead and use it something like that. So once again, we'll go ahead and restart our server here, and then I'll go ahead and do another curl command, run this, and there's our body data coming back, but it looks kind of weird. It says buffer. So the reason for this is because natively, this data is not going to just automatically be turned into JSON data. So to change it into JSON data and basically to accept this application JSON content type header, we just change our Express app just a little bit by doing app.use and it's express.json, just like that. So with this in place, again, restarting our server, what we'll be able to do is we'll be able to run this call again, and now it'll actually echo back that data to us, which means we can now start to actually bring this into our database, which of course is going to require us to do that. And so the actual body, we can go ahead and now say that's the data, and then we can go ahead and say the email is inside of that data itself, and now I can just echo back that email. Great, so here is where we need to insert data to the database. So how are we going to go about doing this? Now, first and foremost, in the DB folder here, I'm going to go ahead and create a file called crud.js. Now, what we're going to be focusing on is the C and the R of CRUD. That is creating data and retrieving data. That's it. We're not doing anything more than that at this point, but once you have this foundation in place, you'll be able to use it wherever you need to. So the main thing here is we want to go ahead and create another asynchronous function, so async function. And this function itself, we're going to just go ahead and call it add lead, or maybe new lead. New lead might be better. And then in here, we just want to bring in the email itself, and then I'll go ahead and console log the email. Okay, so that's that function. Then we'll go ahead and create another function, and we'll call this list leads. And once again, we don't necessarily need an argument here, and I won't console log anything at this point. And then we'll go ahead and do our module.exports and .new lead equals to new lead, and then module.exports and list leads equals to list leads. Now, no surprise here, to actually use this data back into our Expressjs app, we can go ahead and grab it. So what I'm going to do here is I'm going to say const, and we'll just call it crud, and this is equal to require, and this is going to be db and crud. Okay, so the reason for that is then in my leads here, I'll be able to grab my data. So let's go ahead and just say that our results are equal to await crud.list leads, and then our results down here for the data itself, which will be a single result. This is going to be new lead. And then we would pass in this data right here. Now, in my get command, I need to change this to be an asynchronous callback as well. And so that's the goal that we're working towards here. Basically, just have a quick and easy way to add a new lead in and all that. So, of course, this shouldn't be anything new. Nothing about this so far is really that challenging to do at this point, hopefully. If it is challenging, then, yeah, this might be a little bit too advanced for you. But overall, what we want to do now is we want to use this schema to do those two things, getting new leads in our database and listing things out. Now, of course, the first thing I actually need to do is add data in there before I can list any of that data out. So how do we do this? Well, if we jump into our client, we have a database client, but we don't have anything related to Drizzle. Drizzle has its own database clients itself. So if we actually go into access your data in query, what we see here is this Drizzle command right here, where it takes in a client, and then it also can take in a schema. So what we need is just the Drizzle portion of this, and basically we want to have a Drizzle client itself. So now what I'm going to do is change a new client function inside of my clients for my database, and this is now going to be get Drizzle DB client, just like that, roughly speaking. And then the SQL itself is going to go from the other normal get DB client, because we definitely need to use that one. And all I need to do is I'm going to go ahead and grab in Drizzle, and it's going to be equal to require and Drizzle ORM. And what we want within Drizzle ORM is going to be related to the database itself. In our case, the database is Neon, so we'll do Neon HTTP. This is coming directly from their docs. And so we'll go ahead and wrap this SQL client into Drizzle itself. And so now we'll go ahead and export that get Drizzle DB client in here just like that. Great. So that's the first step. Back into CRUD here now. We're going to go ahead and do const client equals to require. And this is going to be our /clients. Or we'll go ahead and say clients in here. And now I'll do const db equals to await clients dot get Drizzle DB client. Great, so this is the Drizzle DB portion. And so what we see in the documentation is we now are at this part. So we're close to doing something like this, and the documentation in Drizzle's documentation for the querying is vast. There's a lot that you could do in here, so we're really just scratching the surface of what you can do. But the idea is something not too dissimilar to this once we actually get into listing out our leads. But before we get there, I actually want to insert new leads. And the way I'm going to do that is by doing const and schemas equals to require and /schemas. And so now with that schema, what I'll do is I want to go ahead and grab in a result, and this is going to be equals to await db.insert. Where we're going to insert it in is related to the schema and the lead table. All right. So we're inserting it into that specific schema. This again is from the documentation. So if you go into the documentation under accessing your data, you can see this insert here. And we see that it says db insert. This users corresponds to what we've been calling lead table. Right? I just made it this way so it's a little bit easier for me to understand what's going on and to unpack at any time. But then we see this .values here, and that's the key of actually inserting the data, is .values and then what data we want to insert. So in our case, our schema only has really one thing that we're wanting to insert in here, and that's the email. But if we had other fields in here, this is where we would do it. We would actually bring in those other fields. So what I want to do here is then this is going to be an actual object we'll pass in here. That object we will unpack and then go ahead and bring it in to the values as well. So email being email. In other words, once we have this data, maybe we're going to go ahead and say new lead object, and then you would pass that in, something like that. But for now, I'll just leave it very verbose, so it's going to be the actual email itself. So what's happening here is it's going to insert that data, but then it's just going to be done. So if we actually wanted to return data, we can do returning just like that. So that will actually return back the result that's come through in here. And we can narrow this down even more if we wanted to let's say, for instance, the timestamp, or let's go ahead and do that. We'll just go ahead and bring back timestamp. And this is going to be the data based off of the schema again, and the data that's being inserted here. So timestamp and then dot. Let's go ahead and grab what the schema value is. In our case, it's created at. So there we go. So this allows me to return back that timestamp as some sort of result. So we'll go ahead and return back that result and see what ends up happening there. Okay, so now it already is in place in that actual location. So I'm just going to go ahead and console, or let's go ahead and echo back the results. I think I have something close to that. I'm going to go ahead and just do results and results. So just changing it slightly. We're not echoing back the data, but rather echoing back what goes into the database. So with this in mind, we want to actually call that one curl command that we were doing just a moment ago with the post. And then I'll go ahead and run that. And of course, it might take a moment for it to fully boot up, and I actually might have to restart my server altogether. So let's go ahead and try that once again. And we'll go ahead and put that email in there. We get an empty reply from server. And so if we come back in here, I get this null column value. Okay, so part of the problem that I'm currently facing has to do with validation, right? So is this valid data? The other problem is how I'm actually passing the data into my new lead. I just talked about it. I actually turned it into an object, and then I unpacked that object right here. So we actually want to just pass in the raw data right here for now. And then we'll go ahead and undo that. So now the request body goes directly into the new lead. But we still need that validation of some kind. So while this is working with this, we'll go ahead and just run it and see if we get anything back from the server. In this case, I do get something back. I get that timestamp back, or at least what I've been calling a timestamp. And notice that I get an actual array back and a list of items back. So what's happening here is inside of this result, it's inserting it into the database and then returning back a list of items. So basically, we will say then if the result.length is equal to, let's say, 1, then we're going to go ahead and return back the result 0. Right? And then otherwise, we'll go ahead and return back the whole list of results themselves. Or we could say null or just an empty list or something like that. But the idea being that if this is a list, then we'll just return back that first the index value in that list. And so returning back a specific timestamp, we can also return back new email, or the actual inserted email, and then just do something like this, right? And that will actually change back what we return. As we can see, we might have to restart the server, but if I go ahead and try it again, let's go ahead and restart the server here. And we'll go ahead and run this one more time. And what we get back should be that email, or new email basically, as the object that's coming back to the Expressjs application. So great. So we now have a way to insert data. Now, in this case, I actually don't want just one single thing. I want all of the data, the entire schema to come back to me. And that's what's going to go into the front end. But we can narrow that down if we were interested in doing that. So now if I do it again, let's go ahead and restart that server again. And we'll go ahead and run this. And what we get, of course, is all of the data, including the ID in here. So at this point, it now seems that I have 7 items in here based off of how many times I submitted it to the backend. And notice that the ID is auto-incrementing. The created timestamp is changing as well. The description has that default text that we had in here right there. So the last thing that we would need to really do with this CRUD is to, build out this list leads. So it's actually very similar to what we've got here, except it's just using different database commands. So when you think about listing things out, you're not inserting in any data, but you're going to be using the same schema. So instead of inserting, we're going to go ahead and use db.select, and then instead of insert, it will be just from. And that's roughly all we need to do. So I can go ahead and get rid of this values here. This time we're just going to leave it as results, and I'll get rid of this altogether. And so I'll go ahead and put that in there just like that. Okay, very simple, very straightforward. And then we can also do something called limit. We can call limit on here on the number that we want to send back. And so now, with this in mind, we've got our leads here. There's our results. I'll go ahead and give out results here as the results. I probably don't need that message in there any longer on either one. So let's go ahead and save that. And this time I'm going to go ahead and just curl the one single leads. So we'll just run curl, which will be a GET request by default. I'm going to go ahead and restart that server. And then I'll go ahead and run that curl command. And what I should see is all of those leads coming back in the item of results. Right? And then again, if I were to submit some more, I can curl it again. And once again, I'm getting more results. So back into CRUD, what we could do is a lot of different things to just make this a little bit more organized, for example. So I'm going to just add in one little quick element here, and we're going to do const, and this is going to be descending, and we're going to say equals to require, and this is going to be Drizzle ORM. Okay, so I'm going to just reorder this and then do just dot order by, and this is a camel case here. And what we want is the sending value of the schema data. So we'll go ahead and grab this schema data here. And then I'll grab the field I want it to be ordered by. So in this case, we have created at. So descending value of created at. And let's go ahead and restart that server again. And then I'll go ahead and refresh this request. And so what we should see is a reordering of it. So ID of 9 is coming first instead of 3. And so if we wanted to see this a little bit further, we can also do like maybe get lead. So get lead would be an individual item, and maybe we're just going to grab it by the ID. And so once again, we're going to select that same table, but now we can use a condition in here called where. And within where, we can actually import something from Drizzle called EQ, as in equal. So we would say where EQ, and this is going to be our leads table dot ID is equal to the argument of ID. And then we'll go ahead and export this as well. So get lead, get lead, get lead. And these results should actually be a single result now, similar to like what we saw with our new lead. And once again, I'll go ahead and grab this single result if it exists. Otherwise, I'll go ahead and say null. Right? So if it's not a single result, then null. Now, this should be a single result because of the ID itself. And so back into our index, what we could do is just try this out with get lead and then some result that we are pretty sure is going to happen, which is the ID of 9. And so let's go ahead and restart our server, and then we'll rerun our call, our curl call, and then this should give us that one single result back, and sure enough, it does. Right? So this where clause is also very powerful because it can filter things down. In this case, it filtered it down to just one thing where it's equal to this. And this, if you're familiar with SQL, this is a very SQL-like command that's happening here. And of course, if we only wanted, let's say, for instance, the ID in here, we could do table.id and put this in as ID and like that. So this is selecting the ID from that value. And then we can curl it again. Actually, let's go ahead and restart that server again and run that one more time. And so that would actually give us just that data. And that would be true whether or not it's an individual item or a listing of items. And so Drizzle gives us this really powerful way to perform SQL without writing a bunch of SQL commands, but they're SQL-like. So it's getting closer to what you would need to do to write the SQL commands yourself. And so while you're learning Drizzle, you're also learning a lot about SQL without writing a bunch of it, and it's really just that straightforward. So at this point, I will challenge you to go into the documentation and just find how you can play around with this data more, because there are so many different queries that you could write, and then of course you would want to update data and delete data as well. But with all three of these, we have a foundation to how you might end up doing all of those things. So I do encourage you to read more about the database itself. But at this point, it's actually pretty powerful where we're at. We can definitely improve it, but as far as an API is concerned to store data, and more specifically email data, this is it. We can absolutely do it. But we are leaving one critical piece out, and that is, of course, this data validation. So that's something we need to do now. Let's take a look at Zod. Now we're going to do some very basic validation using Zod. Now you can absolutely make this more robust by using Drizzle Zod, which actually corresponds really closely to our schemas that we've already built. And then even more robust is... Now we're going to go ahead and use Zod as a way to validate the data we have coming through. Now, eventually you can make this... Now we're going to go ahead and validate our data that's coming through from our request. So I'm actually going to change this data to post data instead, and then we'll go ahead and grab the data itself from somewhere else, which will be a wait, and we'll call it validators dot, let's say, validate lead. And then we'll pass in the post data there. So naturally, we need to bring these things in and actually make them happen. So to do that, we're going to go into our DB, and we're going to create something called validators.js. And then I'm going to go ahead and generate some sort of validation function. So we'll go ahead and do async, and we wanted to call it the function of validate lead. So we'll go ahead and do that, function validate lead, and it's going to take in post data, and then it's going to return some stuff, and we'll do our module exports and validate lead equals to validate lead. So the things we want to return is for sure the data itself, the actual validated data, right? That's a key part of this. Now I also want to see if there's an error. So I'll go ahead and say has error and then maybe a message. Now the reason for that is then I can change the response based off of those two values. So in other words, if the has error is true, then we're going to go ahead and return one type of response. And then if the otherwise, we'll go ahead and say else if the has error is equal to undefined, then we'll go ahead and do another response. Now, if it's undefined, I'll go ahead and just give a message of server error. And has error, the actual status code will be 500. And then if it does have an error in general, we'll just go ahead and say 400. And I'll give it a message based off of the message that's going to come back. Or we'll go ahead and say something like invalid request, please try again. Okay. And then down here with the new lead itself, assuming that that actually worked and we didn't have to do a try block in there, we'll go ahead and change the result to being 201 because that's typically what happens when you create data. The status code will be 201. So with this in place, we need to build out this validate lead function. So the first things are how we're going to respond back, and that's going to be has error true, and then message just being an empty string. So the way we're going to validate this is by using a package called Zod. Now Zod itself is very popular, and it also has a lot of other features to it, as well as integrations to Drizzle, and then maybe even more robust validation messages with this Zod validation error. But what we're doing is something very straightforward. We're just validating the email. We just want to make sure that that's working. So when we do insert data into our database, it's valid data and it's not invalid data. So to do this, I'm going to go ahead and import, or actually install Zod. So we'll do npm install Zod. And then inside of my validators here, we'll do const and z. And this is going to be equal to require and simply Zod. So what I would normally do is I would probably put the schema, the actual validator and the schema together. I'd put them right next to each other because they're based off of each other. But in this case, I'm just going to go ahead and put it in this validate lead function. And so that means I'm going to go ahead and say my lead object validation, something like that, or just simply lead equals to z.object. And then we can start to design or format what we want to validate in here. And so what's going to happen is we can put any sort of data in here. We can put a name, we can put an email, we can put a description, and then in here we can put those things that correspond. So like name, email, description. We can fill these out more, but the idea is what you put in here might correspond directly to what's inside of the lead itself. So in our case, it's just going to be the email itself. So instead of name and description, we're just going to use email. And the way we validate that is by having an actual dictionary, an actual Z object in here. And that means z.string. So we definitely want it to be a string in here. So it's not going to be a number, that's for sure. And then we can use .email as well. And so using .email is another method that's available to us because of Zod. So if we look in Zod and do a quick email search in here, we can actually see some validation that's going on. And there are a lot more places where we can actually call email, and you can actually see that in the baseline validations. So we can also validate the size of it. We can make it bigger or smaller, right? We can validate the length of it, which is similar to that. We can do what it starts with, what it ends with, if we wanted a certain domain name. There's a lot of different things on how we could go about doing the validation itself, which is beyond the scope of what we're trying to do here. I really just want some simple validation. And so this is really designing the way we're going to validate it. Then when we actually want to validate it, we will use lead.parse. So let's go ahead and say let's do valid data equals to lead.parse. And now what we're parsing is we're actually going to pass in an object of some kind. So this needs to be an object, which in our case it is. It's the request post body object itself. And of course, if this is incorrect, it's going to run a validation error itself. So I'm going to go ahead and run catch and error. So we want to put it into this catch statement like that. And basically what we would do then is say let has error, right? So we'll leave it as undefined. And then I'll go ahead and say has error equals to false, and then has error equals to true, right? So if it doesn't have an error, then we will, set it accordingly. So the error is only going to come when we try to parse out this data. So this valid data really is actually going to be let valid data, and I'm going to set this equal to just an empty dictionary. And basically, that's what's happening here. This parse call is going to parse out all of the data that I actually set inside of here. So if the post data had a name, for example, it's only going to validate the things that I declare. And it will only return the things that I declare. So that now that I've got this valid data here, I can actually pass it in. And then we'll go ahead and just do let message. And then I'll give it a message of equaling to an empty string here. And then the message being invalid data. Invalid email, please try again. Okay, so now we've got our validations and our various validation errors. So let's go ahead and try to run this now. So npm run dev, and then I'll go ahead and do a curl call in here, just like we've seen. I'll go ahead and run this. I get an empty reply from the server. So let's go ahead and see what's going on. My validators is not defined. So let's go back into this page here, and we'll go ahead and bring in our validators, the entire module. Let's make sure we exported it, and it looks like we did. So let's go ahead and try that again. We'll rerun the server, and then I'll go ahead and trigger a call, and I get invalid request, please try again. So that invalid request, please try again, is coming from this right here. So the message doesn't seem to be coming back from this validate lead. So let's go ahead and see why. Let me bring this back here. So we've got our message. There it is right here. I need to go ahead and pass in that message. So we'll save that, and let's go ahead and refresh that server again. And then we'll go ahead and come back in here, run it again, and now I get invalid email, please try again. So let's go ahead and do an actual valid email by just putting this at the @sign, hit enter, and now what we should see is, of course, the database is going to have to spin up, and then we see this. So the nice thing about this validation is it's actually not going to hit our database until it's actually valid data, which is another reason to do this. And of course, this is sort of the basic level of doing this kind of validation. The more robust and more advanced level would be using Drizzle ORM, because you can build out schemas based off of other schemas. And what I would actually do from here is to modify my schema validation that I've been doing and do something along these lines, where it's insert user schema. And you could import that in this validate lead if you'd like, or you could just use the schema directly in the view as well. But the reason I like doing this validate lead here is I can actually have a little bit more robust methods. But of course, there's nothing stopping you from actually putting in the post data itself. So yeah, that's how we can actually validate this data. And we do it using Zod feel free to make this more powerful and also research a little bit more about Zod itself on how you can just do that much more validation. To me, the validation is as good as you can actually use it, as you can actually implement it, right? So I could definitely spend a lot of time trying to figure out how to give a much better message than invalid email, as in the validator itself actually will give you better validation errors than just invalid email, right? So I can actually see what those messages would be directly from the validator itself. So let me just show you real quick. If I restart this and we do an invalid data again, I run that. Again, it says invalid email. If I go back into the node, I can see just exactly what different validation errors are going. So yeah, we can absolutely make the messages themselves much more robust than what we've got here. But to me, it's like we better just validate the data and then provide some sort of message that makes sense as well. So another thing that you could consider doing in addition to validating the data is you could also check to see if it already exists in your database, right? If it's already there. And the way you would do that is very similar to like what we were talking about with CRUD, where it's like listing out the leads, but more specifically looking where the email matches the requested email. And if that exists, then we run another sort of validation error, which is something that's outside the scope of this, but we're working that direction. The key of all of this, whenever it comes to inserting data from the internet, is you almost always want to clean that data and validate it before you want to send it into the database. The database itself will help with the data types, whereas the validator itself will help us with these kinds of messages and prevent as many database server errors that there could possibly be because of poorly formed data. So yeah, validators are great and fairly important. So yeah, hopefully you start using them now. It's pretty simple, and of course it can be a lot more robust, thanks to Zod and its powerful tooling. So let's keep going. Now we're going to go ahead and automate the process of staging our application. So like the dev stage, for example, when I make some changes with the code, I want to be able to deploy it to GitHub, and then GitHub automate the process of deploying the application on AWS Lambda, but also branching our database at that point in time so we can work off of that. And the way we're going to do this is by, of course, updating our secrets. This is the key part. We actually need to update our secrets for that stage. So if you think about this in serverless.yaml, we have our production environment going through, and this database URL, well, we actually don't use that anymore. So we're going to be gone altogether with that one. So what we need instead is really the stage itself. And so this is going to be based off of an environment variable that we will then later set. But the default stage is going to be prod. We're going to use the production stage as default. Now, the reason for this, of course, is going into our secrets here, where our database URL is actually stored. That's where that stage is being set, right? So then in my get database URL, I can actually modify what stage is going through. So in other words, in my dev stage, I can add in stage of dev and get rid of this database URL right here and get rid of it basically anywhere so we don't accidentally expose it when we don't need to. So of course our AWS access keys have the ability to get that database URL that's stored in this parameter. Of course, one of the things that you're thinking about, hopefully, is the fact that we set this parameter manually. So we actually went into AWS to set it manually. That isn't automated. It's quite literally the opposite. So what we need to do is we need to automate the process of not just the stage itself, but also setting in that database URL. Now, luckily for us, actually using the Neon CTL, it's really easy to branch the database. So if we look at the branches that are available, we can see that with Neon CTL branches and list. We can see all the branches that are available, and right now it's just the main branch. So if we want to create a new one, we could do it like this: create name and then like dev, right? So that gives us back this connection string here. And of course, if I wanted to use that connection string or just the connection string, I can use Neon CTL and connection string and then the branch itself of dev. And so that's going to be the exact same connection string as we see. And so this one we want to treat as ephemeral. We want to be able to delete it at any time and then branch it later at any time. Both things we want to be true. But that presents a new challenge with our production application. And when I say production, I mean one that's running on AWS Lambda, regardless of the current stage itself. So we need to be able to automate the process of updating our parameter store. And luckily for us, it's actually not a whole lot different than getting data. So we'll go ahead and do that now. And let's go ahead and put data. We'll do put and parameter command. And that's the command we're going to use. Now it's almost identical to this get database URL. So I'll go ahead and paste that over and copy it. And so the idea then is the param path needs to change based off an argument. So we'll go ahead and do the put database URL. And there's going to be a stage that will pass in here. And I'll just call this const param stage, which is going to be equal to the stage that's coming through. And otherwise, it's going to just be simply dev. What I want to check right away is if the param stage is equal to the prod. Then I'll just go ahead and return. I don't want to change the production stage ever, right? I don't want to change this automatically. That's something I'm happy to go in manually and change if I need to. And so this param stage is now going to be what the actual path is for this item, or really the database URL name, which of course comes down here. So we go based off of that param stage. And now we'll be able to modify it in just a moment. So this put URL, database URL, we actually need to have the DB URL value as well. And so that's going to be part of the arguments we'll end up using. Everything else is pretty much the same. Of course, if we wanted to change the region based off of our environment variables, we could totally do that. I'm going to leave it in as just the default one that we've been using. Because I'm not really going to be changing anything else. But the idea here is the other parameters that we want is the value. So we'll use value here, and we'll pass in that database value. Now, once again, if that value does not exist, then we'll go ahead and return this element here, and basically it's incorrect. It's not going to work. So we still want to use this decryption, but the way we do that is instead of with decryption, we just declare the type itself. And this is going to be secure string. And of course, we need to put that in a string itself. So the idea of secure string is, of course, coming directly back into the console itself. When we did create a new parameter here, we have these three type options here. I'm just using secure string and all of the other default options in there. Yes, there are ways to modify this as well, so feel free to look at the AWS SDK documentation for that. Next up, the final thing is overwrite. And I'm going to go ahead and say true. So basically, whenever I want to put a new stage database URL, I want to overwrite the value that's currently in there just to make sure that it is my latest value. Of course, there could be issues and errors with this process, which is why we don't do it with our production database. We only do it with everything that's not production, everything that's not the main stage that we're using. So of course, the final commands are basically the same, but instead of get parameter command, we'll use put parameter command in there, and then I'll just return the result. We'll save it just like that. So before I go any further, I will tell you now, we can also do something called a delete parameter command, where we can actually delete and basically undo everything we just did. And it's a little bit closer to this get URL, where you just basically use the name itself. But the reason I'm actually not going to be deleting the command itself is it makes it a little bit more complicated. But also, since we are going to be overwriting the database on a regular basis, it doesn't really matter if that's the correct connection string or not. So I'll go ahead and just leave it in as just put. Next up, we'll go ahead and do module and exports.put database URL. We'll go ahead and export that out so we can start the process of automating it. Now, the way we're going to automate this is by using a command line tool. We're going to make our own command line tool. So we're going to copy this migrator one, and I'll go ahead and just call this put secret.js. Now, this is actually more like put database secret. So maybe you want to change the name of it, but I'm not going to change the name. Now, first off, the migration command, we don't need this function anymore. We already have a function. We just created that function on what we're going to end up doing. And so I'm going to go ahead and get rid of all of the things related to migrate. Now, the main reason I actually copied that is to remember I definitely do need the .env configuration. Because remember, in order for me to use the AWS SDK itself, I need to have the environment variables for the AWS secret access key and the ID. Both of those things I need in there, which is exactly why we've got this command line tool going and why I like copying these other command line tools that use the same sort of stuff. And so now the question, of course, is like, what are we going to put in here? So before I do that, what I want to do is I want to declare args, and there's going to be process .argv, and then we'll go ahead and do slice of 2. Now the reason I have slice of 2 is because the way this works is going to be the same as the migrator, but of course instead of it being the migrator, it's going to be put secrets, and then we'll go ahead and do something like stage and then the DB URL. So this is going to allow me to get everything after like basically these two items here. And so all I want to do then is just check if the args.length is equal to 2. Then we're going to go ahead and do process.exit1. That's it. So we just want to exit it and say something like along the lines of console log and usage is that. Simple enough. Okay, so now let's go ahead and try and run this one. I'll copy the relative path here, or basically run TSX. So I'm going to go ahead and clear this out. We'll do npx and then TSX run all of that. I'll start out with hitting enter, and it'll say run migrations. So this is a problem. This should be not equal to 2. Let's try that again. We run it again, and now it's giving me the usage itself. So we'll go ahead and try dev and then some db URL. Hit enter, and now it says run migrations, which of course should be, update secret, right? Something like that. There we go. So how are we going to update the secret? Well, we're going to grab the arguments themselves. And the way we do that is by doing const stage and db URL, and it's going to be based off of those args. So this is, of course, is unpacking it based off of the position it's in, which means that if we accidentally do the incorrect position, we've got some issues here. So this might be where you want to check if the stage is equal to like dev or something along those lines, and then go ahead and run everything else. I'm not going to do that. I'm just going to assume that we can have any stage we want and any database URL we want. So we'll go ahead and set the actual secrets now from our new secrets function. So to do this, I'll go ahead and say const secrets, or secrets equals to require and lib and then secrets. Okay. And we'll do secrets.put database URL. What do you know? We can put in our stage and our DB URL here. So the idea here is it is an asynchronous function, so you want to do await. But the nice thing is with asynchronous functions is we can actually treat them as promises. So we can just do then, and we'll go ahead and say value, and we'll do console log secret set, and with that value, whatever that might be. So we'll go ahead and do value, and then put these into backticks. And then process and exit being 0, because it's successful. And then we'll go ahead and do catch, and in this case it's going to be error. And once again, we'll go ahead and run something similar to this, but now secret not set, and the error, and we'll go ahead and exit at 1. Okay, cool. So now that we've got this, let's go ahead and set a secret. I'll just go ahead and run this value here, hit enter, and we've got update secret, secret set object.object. So what is the object that's actually being logged in here? So we'll go ahead and do console log value, and then we'll go ahead and do secret set, and let's just call this updating, database URL. Let's try that again, and we run that, and here's the value that comes back. Now this is the default result from the actual put database URL. That's what this is right here. So we can actually see that the status code is 200, which is successful, right? Of course, we could also then get the result. We could quite literally use something very similar to what we did with this get database. We could quite literally go and grab the result itself to get the actual value, but it's not necessary. Really, we just need to know that the status code is 200, and I'll let you unpack that and handle those errors later. But overall, we just want to verify that that secret is actually in our parameter store now. So in the correct region that I set it in, I'm going to go in here, and what do you know? There it is. And so I'll go ahead and scroll down here and debug the value or decrypt the value, and we've got our some DB URL here. So it's definitely working. It's actually putting that database in there. And every time I run it, it creates a brand new version of it. So I can refresh in here, and we can see that version. And that thing is actually changing. So if I change it again and refresh in here, we can see what that is. So actually the nice thing about this is there is a way to get different versions of it as well. So if for some reason in the future you wanted to be able to change this to different versions, you could totally do that, which is pretty cool. So now we actually need to put the correct database in there, right? So again, using this same idea, we're going to now do our Neon CTL, and this is going to be our branch, or rather connection string. And then we want to get the branch of dev. Okay, so this is going to be that connection string. The way I'm going to automate this is by putting it into a export command. Now, if you're on Windows, this right here is not going to work for you until you go into GitHub Actions. There's a way to do it. This is just not it. Anyways, so we're going to export this as our, we'll go ahead and do this, our database. Let's call this our stage DB URL. And this is going to be grabbing it just like that. Okay, so now I can use npx right here, dev, and then use $ of that, and oops, not $ equal $. Let's get rid of that $ equal $. And now we've got the updated database version 6. Let's go ahead and refresh in here. And so now we should actually see that database URL, and it's there. So of course, we just need to verify that that part is actually working. And we can do that thanks to, of course, this process.env.stage, and our env dev has that stage as well. So let's go ahead and run our local npm run dev, our local application version, our offline version. Notice that that stage is coming in there. So one of the things we might also want to check maybe is on our home page is putting that stage out there. So let's go ahead and grab that argument like this. And we'll go ahead and put this on our home page just to make sure that we actually are using the correct stage in that environment. So let's go ahead and restart that, run it again. So I'll go ahead and open up localhost. And so what we got is that stage of dev. So what we can see then is we can actually start adding in some data. Now, of course, inside of the Neon console, we can verify this as well. So going into the tables, we see that we have our main branch and our dev branch. So let's go ahead and add a few leads in here. And of course, the way I'm going to do this is by using that curl command. So let's go ahead and I'm just going to copy and paste what we used in that last part. But there we go. I'm going to run this a few times. And then I'll jump back into my Neon console here. And we should see all of those new leads. And we do. So if I go back and change the branch to main, something like that, and also see those new leads, they are not there. So it is now working on that branch, which is great. So of course, the last few things that we would really need to do is to push this into production. But one of the things that I also want to make sure that I'm doing when I actually run this is inside of package.json. Perhaps this is where I'm going to want to run that command just to remember it. But the thing is, since I'm going to be automating it, what I'm really going to be doing is using this inside of GitHub Actions itself. So this is going to be a GitHub Actions CLI command that will run when we get there. But overall, this is fairly straightforward on how we can set the staged URL and set the branch. So of course, the last thing that we could really test here now is to delete that branch and do it all over again. So we'll go ahead and do that with Neon CTL, branches, and list. All right, so let's just make sure it's in there. I'll go ahead and do branches and delete then the name of dev. All right, and maybe just dev. Try that again. There we go. And so we've got our deleted branch now. So let's go ahead and create a new one, Neon CTL branches, and create the name of dev. Okay, so I'm going to go ahead and scroll up a few times to get that database string again to our environment variables there. And then I'm going to go ahead and use it once again like that. So I'm putting that secret on there, updated. It's number 7 now. We can verify that it is a different branch. Let's go ahead and take a look in the parameter store. And we'll go ahead and refresh in here. And so I'm going to do a quick search. We got EP Soft Glade and we got EP Soft Glade. Great. So let's go ahead and refresh our node again. And let's go ahead and add one more. So if I remember correctly off the top of my head, this is going to have 13 or 14 items. So this should be item 13. And we see that with ID of 13. We do it one more time. We got the ID of 14. And so now that same exact branch that we originally tested on is gone. And if we look at the new dev branch, we can see that it's down to 14. And of course, the time and all of that has changed. Great. This is awesome. So the next part of this, of course, is now turning this into a GitHub action that it does all of that for us. So we don't actually have to touch it anymore. So let's go ahead and take a look at how we're going to do that now. Now we're going to go ahead and use GitHub Actions to automate our deployment stages. First, we'll automate the production deployment and see how that works. Then we're going to go a little bit more advanced and use a different Git branch to deploy a different stage, the dev stage itself. Once it's deployed, then we will go ahead and submit a pull request to the production branch to have that run then at that point. So I actually already started with some of the workflows themselves. So if you were interested in going from what we have now, just go into the workflows on GitHub, and we're going to go through these things right now. So the idea behind GitHub Actions is it's a serverless way to just run some code. The code we run is really up to what we define in these GitHub Actions. So in our case, what's happening in this production one is it's going to go ahead and grab a copy of our code. It's going to set up Node.js and specifically version 20, and then it's going to go ahead and run our npm install and then run our npm run deploy, which of course is this command right here. And so that's it. That's the production stage itself. Now, one of the dependencies this production stage has is the actual environment variables from AWS. So let's go ahead and start this off right now. Let's go ahead and put that into our GitHub Actions repo. So inside of our settings here, there's a couple of things that we want to do. The very first thing is under GitHub Actions, we're going to go into General. We want to go ahead and scroll down and allow for workflow permissions to read and write permissions, as well as allow GitHub Actions to create and approve pull requests. Those things are important for what we'll do in the staging process. The next thing is we want to scroll to the secrets and variables in the GitHub Actions section, and then we'll go ahead and scroll down to repository secrets. This is where we're going to put in our environment variables. Okay, so what we want to do is these two variables here. So the first one is going to be the access key ID. I actually want to create a brand new access key ID specifically for GitHub Actions. So inside of IAM, I'm going to navigate to my user here, into security credentials, go into access keys, create a brand new one. We'll go ahead and say other. Next up, we'll go ahead and give it an actual description this time. So GitHub Actions secret, basically, or GitHub Actions workflow, basically. And we'll go ahead and hit create. We're going to grab that access key there, and we're going to bring it into our GitHub Actions secret. We'll go ahead and create that one. Next, we're going to go ahead and create the secret access key itself, and we'll scroll down and paste this in here. And then I'll go ahead and copy this secret access key and paste that just like that. Okay, great. So now our GitHub action should have everything necessary to deploy our production application. So I'll go ahead and run this workflow. Now, the nice thing about these workflows is they are fast and efficient, and they have really good logs to figure out what's going on and what might be wrong with them. So one of the things that would have been wrong is if I didn't actually fill out these secrets. Now, something that's cool about how the environment variables work in the serverless application is that it will use the AWS access key and secret key instead of using .env. So that's actually a really nice feature of the serverless framework. So the next thing I actually want to do is I want to put the stage here, and I'm going to go ahead and say it's prod. Now, the reason for that is because in my dev stage, I also want that to be dev, which I already have in there, but I just want to make sure that I do have that in the production one. That also means that since I'm declaring the stage in more places, I want to make sure that when I'm grabbing my database secret, that stage has an environment variable one. Right? So it's certainly possible that you're just like, oh, I'm just going to use the production one, but hopefully you didn't do that based off of a number of things that we did with the last part of actually setting and automating the secrets themselves. So with that stage in mind, I also want to update serverless.yaml, and I want to change the IAM role here to also match that stage. Because originally it was just for the production stage. We only had one stage really creating a role. Now we're going to have multiple stages creating roles, so we just want to update that as well. So we're going to save everything, and then in my GitHub, I'll go ahead and update these. And we'll go ahead and say prepare for stages. And we'll hit commit, and we can sync those changes at this time. Okay, so back into GitHub, notice that my deployment actually did happen, deploy our production app, and it happened in 43 seconds. We can click on this deploy section here, and in here we actually see our endpoint come through, so I can open that up, and sure enough, this should actually work for me. And then if I go into leads, I think I just get one lead back based off of some of the configuration we set up, which of course we could verify in our code itself for leads, the actual default page we actually have git lead in here instead of git leads. Okay. So now that with this change, it's a minor change that maybe I want to be in dev first and to the dev stage first. So what we want to do is in our prod stage YAML, I want to change this a little bit to being based off of pull requests. So in other words, my dev stage workflow is going to have to generate that pull request. So that's going to take a number of steps, and it gets a little bit more complicated than what we just did. So if you want things really simple and you just want to run just straight to production, which I don't advise, but you definitely could, you could automate this with a push request and basically change this to the branch that you're going to be using for your main branch or your primary branch on GitHub, which would just be main. And then if you had this active, it would automatically run that workflow that we just did, workflow dispatch. Okay, so I'm going to go ahead and just leave only workflow dispatch for now and work on the dev stage and really figure out what we're going to be doing here. Now, we already have a few of the environment variables in place. We do not have the Neon API key, which we'll need in a moment. We have our stage here. We also already have a built-in GitHub token. This is provided to us by GitHub Actions. We don't need to set it. We don't need to find it anywhere, which is really nice for later when we use the GitHub CLI, which actually comes in by default, which we'll see in a moment as well. So again, we actually check out the code itself. We grab all versions of the code, mostly for the pull request action that we'll do very soon. Once again, we set up Node.js. We do the installations, the default project installations. Then I want to make sure that I have the Neon command line tool and TSX. This, of course, is so that we can automate creating the branches like we've seen before, as well as actually getting the connection string and then outputting that into our AWS secrets, that parameter store. So all of this stuff is mostly things that we've already seen before. Something that's a little bit new now is this API key call. So basically anywhere we need to run a Neon CTL command inside of GitHub Actions workflow, we just pass in an API key in there, and that's how we're able to do all of these things. So how I designed this workflow was to delete the previous dev branch so that I can take a point-in-time version of the branch or of the actual database itself to actually create a new version of the dev branch at that time when I run this workflow, so that then my staged dev deployment actually has a new branch from the database itself. It actually is working off a new instance of the database, having more of that data that's been stored from the production branch. Now, of course, that's optional. You don't have to do that. I just want to show you how it's done. Next, of course, is getting the actual connection string itself from that branch and then putting that into our secrets. And then finally, we're going to go ahead and grab info about the branch itself. So this is the one I want to run. So in order for this to work correctly, we need to bring in the Neon API key. So let's go ahead and do that now. I'm going to go into my production app here. We'll go into settings. I'm going to go down into those secrets again. And we're going to go ahead and create a new repository secret for the Neon API key. Now, where we find this is in the Neon console. We go into our user account, go into the profile, go into developer settings, generate a new key here, and I'll call this GitHub Actions. And then we'll go ahead and grab this and bring it into GitHub Actions. Now, do be aware that this key right here has access to our Neon project, so it could quite literally delete all of our databases, which might be something you want to have happen, but it also might not want. You also might not want that. But just keep that in mind when you do actually use that API key itself. Okay, so with this in mind now, we're going to go ahead and run that GitHub action. So I want to bring that dev stage in here. So we'll go ahead and do git status, and I'm just going to go ahead and say updated all for dev. We're going to commit it, and we'll go ahead and sync those changes. And then back into GitHub Actions, I'll go ahead and deploy this dev stage now. So the key thing that I've been doing so far is actually just working on the single branch of main here. So what we actually want to do is work on a different branch. We want to work on a dev branch specifically with Git. The dev branch will correlate to the dev application, the dev stage of the application, as well as the dev branch in Neon. So it's going to be dev all across the board just to keep things consistent, and so I know exactly what's going on. Now, the way we do this locally is by doing git checkout -b, as in branch, dev. And this switches us over to the dev branch. So all of the changes we do in here will only go into this dev branch until we merge it into the other branch itself. So that's into the main branch, that is. So for example, if I change this right here, I just change that one single push on this workflow. We'll go ahead and say updated dev branch. Go ahead and commit this. And I'll go ahead and publish this branch and push it into GitHub. So now back in GitHub, if I refresh in here, what I should see is something related to my dev branch. So I have this branch here, and I have the ability to now bring in and merge these two branches together, right? So I can actually merge the dev branch with the main branch itself. So it's one commit ahead, as we see here. By just changing it, we can go ahead and create a manual pull request and go ahead and hit create pull request here. And then now I've got a pull request, right? So in my case, it says 11 just because I did a bunch of testing. Yours hasn't, or yours probably will say 1 maybe. And then we can just go ahead and merge this and go ahead and confirm that merge. And then we can also delete that branch if we wanted to. And so all of that did was now in our main branch, we still only have one branch in here. And then in my workflow, we can double check in this dev stage here that that branch was actually pushed. It actually did something in here. So it actually did make a change into that workflow. So let's go ahead and actually do this once again. And it's still on the dev branch and still doing it manually before we automate it. So the way we're going to do this is by going into index.js. This time I'm going to go ahead and get rid of this homepage message. Right? I just want the delta, and that's it. So I'll go ahead and save that, and we'll do git status, git add, git commit, updated homepage, and then git push. Okay. So once again, it pushes it, and then we can go right here and click to create a new pull request and do that right here. Now, before I actually create that pull request, I want to modify my production one just a little bit. So back into the production workflow here, I've got this pull request, and we can do this types of closed. So when the pull request is closed, it triggers a GitHub event for that pull request, and we can verify if it's merged here. So if it is merged, then we could run all of the production deployment stuff. So we'll save that. And now we'll go ahead and do git status, git add -- all, git commit, prepare for auto deploy via merged PR. Go ahead and push. Okay. So now I refresh it. Everything should be up to par. And I'm going to go ahead and now create this pull request. I could have created the pull request before, but now I have it. No descriptions in here yet. But this pull request, now when I actually merge it, what should happen is it should actually start a deployment process. But since I just pushed some code into the dev stage itself, I might want to actually wait for this to finish before I run anything else with serverless, or maybe not. I don't know. Let's go ahead and give it a shot. I'm going to go ahead and merge this pull request and delete the branch. So go ahead and merge, confirm merge, and delete branch, and it's deleted. Going back into our GitHub Actions, now we've got this deploy production app. It's starting to deploy it based off of that merged pull request. Cool. So if we wanted to automate this, it's just one more step, and it's a sort of major step inside of the dev stage, but not really that major. And all it is taking this branch information here and then using the GitHub Actions PR create command, which is the GitHub command line tool, to actually create a pull request for us based off of this actual branch and the branch that we're going to. So what we want to do then is actually run the command here. So I'm going to go ahead and say title, and we'll give the title of automated PR from dev, right? Or really from dev stage. Okay, so that's the title we'll give it. And then I'll go ahead and pass in a body and coming soon for now. And then I'll go ahead and pass in the actual base branch, which is going to be our default branch. And then the PR branch is going to be the next one. And that's going to be head branch. And there we go. And then we can also do our GitHub repo in here and just say repo and the repository. Okay. So there we go. We've got our branches that we're going to do here. And let's go ahead and see how this ends up working. Once again, I'm still in that dev branch here. So I'll go ahead and do git status, git add, git commit, and we'll do updated dev workflow for auto PRs. Git push. Okay. And that's going to take a moment for that to finish. So going back into GitHub Actions, we see that the production app was successful because it's really not that different than what we've been doing. The pull request itself, I should have none in here. If I have any dev pull requests in here, this GitHub action will fail. You can't have more than one for any given branch. Now, there are more advanced ways to have multiple branches and stuff like that. I'm not doing those advanced ways. I'm just going to be doing this really, hopefully, simple and straightforward one. Okay, and so we've got this branch info here, which I need to change the name of it, but it does do the PR. Looks like everything was successful itself. And then we can see the branches. The PR branch is the dev, and then the main branch is right there for the default branch. Great, so now we can go into our pull requests here, and there it is, our automated PR from the dev stage. The actual body itself needs to change. We'll change that in a moment. But overall, now I can actually merge this data. And again, I can delete the branch if I want to. It's really up to you on if you keep the branch or not, because locally I can still work on that branch and then push it again. So the last part of this is really going to be do our pull request. So it's going to be our dev stage pull request. And what we want in the body data itself, instead of coming soon, we want to actually get the info from our deployment, right? So the deployment info itself, which is going to be in here, so we need to update that as well. And so let's see our dev stage. Looks like our dev stage has been running our deployment in here as well. No, our dev stage is actually missing the deployment and the info. So that was a key part that is missing, but let's go back into package.json and make the deployment happen for our dev stage as well. But overall, the GitHub action stuff is working correctly. It's just there's one piece that was missing, which is deploy dev stage. And then, of course, this is going to change it to just simply dev and all that. Next up is we're going to go ahead and get info, dev stage, and info. Now, the reason for this is going back into the dev stage itself. We'll go ahead and just grab one more name here, and we'll go ahead and do deploy dev stage. And then we'll go ahead and run the npm run deploy dev stage. And then that's going to take as long as it takes. And then down here, we're going to go ahead and get export the dev stage info equals to the $sign of npm deploy and now info dev stage. And then that is what's going to be inside of this body right here. We're going to go ahead and pass that in just like that. Now we've got a new body stage, and let's go ahead and try this out with git status, git add dash all, git commit, and updated. Put the message in here, updated for full dev deployment stage, git push. And of course, we'll let that go through. I need to make sure that my pull request is empty. Looks like it is. Of course, if I were to cancel any of the pull requests in here or deny them, the production stage won't run. It will only run if they are merged, and that's it. Great. So there's obviously a lot of options on how you could actually go about running those things as well. Now I'll just go ahead and let this finish so we can just kind of polish off this GitHub Actions workflow. And there we go. The workflow looks to be successful. So let's go into our pull requests here. Now we can see the automated pull request from the dev stage, and what do you know? There is the endpoint URL. So much of this pull request was reliant on this so that somebody could then go in and review some of those changes, right? So we would actually be able to open up that page into like a new tab and review what's going on. I made something change to the leads, and I get this internal server error. So clearly that's something I do not want to actually have go into production. So then let's go back into our local environment here and see what's going on with that problem. And then we'll go ahead and just change and see how we might fix it. So of course the leads itself is having a problem. Get leads is simply not a function. So let's go back into our actual DB CRUD, and it's list leads. There it is. Okay, so we found the error itself. Go back into our index page, fix this error in our dev stage still, git status, git add, git commit, updated to list leads, and then git push. And then again, that's going to go ahead and run through and finish. And so this is why we actually have those PRs in place, is to just do some checks to make sure everything's good. In this case, we do not want this. We're just going to close this pull request, and we will delete that branch as well. And that's it. So we actually do not want that one. Of course, we could put comments and stuff like that. But once you close it, what will not happen is the deployment actually running, right? So this won't build it, it won't go through. And the reason, of course, is it was skipped because of the way we set it up in that nothing merged, nothing changed. And so that is also showing that this is working correctly as well. So that's actually pretty exciting to me, I think, is we can now see the dev stage in its full capacity. We can do all sorts of tests there. In the sense that I could even share this with developers and stuff like that to go through the different tests that they might need for this particular API. And so, yeah, granted, this is beyond the scope of really building out a Expressjs application because the GitHub action itself could be used in many different places. But the thing that's really nice is our dev stage itself has a lot of features built into it that are really only possible by using Neon's database service and as well as using AWS Lambda. And of course, it's because when I'm not using the database or the AWS Lambda, it's not charging me. It's practically zero cost to be able to have this deployment stage or this dev stage that I can then use when I need it to use, and then that's when the cost will start to incur, but only for a few minutes or so. Now, of course, I get this little error here, and I think it's related to actually deleting out that branch too far in advance, so I'm going to go ahead and just make another little change. I'll just add a line here and do git status, git add -- all, git commit, and minor fix, and then I'll go ahead and push this just to verify that the actual GitHub action is working before we call this part all said and done. And there we are with that minor fix that should be in there. So I'm going to go ahead and now merge this pull request. And again, we can test this out as we see fit. And I'll go ahead and run this and confirm that merge. And I'm going to leave the branch now. You could absolutely delete it if you needed to. But I think one of the problems that we saw with that previous minor fix, or at least the updated to list leads, the problem was that, well, when I went to merge it, I think it deleted it during the GitHub action workflow running, which caused that issue. But now we've got a brand new one where it's going to go ahead and go into production and all that. Now, the other thing about this is the actual production workflow does not have to actually go into using serverless at all. We can now pick wherever we want as far as when this thing gets merged and all that. And of course, the actual source code itself is going to change based off of that being merged. And there's our list leads in there, like that, and also that just little extra space in there to make sure that that is all working as well. So it's fairly straightforward on how we go about going from here. The most important part of all of this was making sure that we could automate the dev stage itself. So now at any time when I need to make a change to my code, I work in that dev branch and then commit it and do all that. Let the dev stage actually do its thing, so then my main branch can actually work based off of that whenever I need to. So I basically won't need to work off of the main branch any longer unless there's some serious reason that I really need to. But of course, if I were working through this dev branch and running through this dev stage, I should be pretty good from here on out. Yeah, GitHub Actions is pretty great for a lot of reasons. Let's take a look at another place to deploy this application than just AWS Lambda, but still working in everything that we've been working with. Now, as you may know, Expressjs was not really designed for the serverless world. But the reason we can actually run it in serverless is, number one, it's a minimal framework. There's not a lot of overhead to run Express itself. Number two is that we have serverless environments out there that we can run it on, like AWS Lambda. It has Node.js and it can actually run Express for us. But almost as important, if not more important, is actually our database. So as soon as Expressjs needs a database, something like Neon in serverless Postgres is how we're actually able to run and execute all of these things effectively without overloading our database and being ready to scale up if we need to. Now, of course, a better option for serverless is probably Next.js. Next.js was designed for front-end and back-end operations. Those back-end operations are designed to be running on serverless. They're like small little functions that can just run on serverless, and it's really, really fast. But the thing is, you actually have to learn React to really get the most out of Next.js, and maybe you're not ready to do that yet. But what we will do is we're going to go ahead and integrate everything we just did with our project and bring it right into React where it feels very native to our Next.js projects if you start building them out. And this is thanks to Vercel. Of course, Vercel manages Next.js, but also they made it really simple to have some rewriting of rules for our API routes, as we'll see in just a moment. Now, generally speaking, Expressjs is not going to be deployed directly to Vercel, but I want to show you a way to do that as well, and that's something we'll do in a moment. But first, let's go ahead and see how we can actually integrate Next.js with our entire ecosystem that we've already created in our serverless Expressjs application. So I actually created a repo specifically for this one, and the only thing that you need to change for this repo is in Vercel.json, this rewrites here. That's all we need to change to make all of this work, and more specifically, the actual destination like we've got here. Now you can simply clone this project, or you could just go to your local computer, run npx create next app at latest, run through all the default options, and then you just want to bring in this Vercel.json here. And so what we want to do is we want to have these rewrites in here because of how Next.js handles API calls. So inside of Next.js, you can actually add in a place to run backend API calls, which is why we're actually doing this rewrite. So basically, we can treat our backend that we already have in existence as one of the routes that you use for the backend of your Next.js application. So that's what we want to implement. Now to do this, I want to jump back into my serverless Node.js API application. So in here, I'll go ahead and grab that with my serverless and info, and then we'll go ahead and grab the stage being prod, and then the region being the region we've been using, which is US East 2. Hit enter, and this will give me the actual endpoint I want to use. So I'll go ahead and copy this endpoint, and we'll paste it in just like that. Okay, so I'm going to leave it as is, and then what I want to do also is I want to make sure that Vercel is installed with npm install-g Vercel at latest. The reason for that is so we can actually use Vercel to, run these rewrites. Traditionally, Next.js does not need to run those rewrites. It won't actually do it by default. So using Vercel will allow for that to happen. So we'll go ahead and just call Vercel to start out. It's going to ask us to set up a project. I'm going to select all of the defaults in here. I don't need to set up an existing project. I'm going to use the directory's name. I'm going to keep it in the local directory itself. I'm not going to modify any settings. And now it's going to go ahead and push this into Vercel itself and maybe even make a production version of this. So we can verify this by going into our Vercel account, which of course I'm in a free account here. There is my application, right? And so we of course want to have a production build, and we'll do that in just a moment. But before I do that, I'm going to go ahead and create a new item here, and we'll just call it Vercel and dev. So this is the Vercel development environment that's running our Next.js application with a port value, which in this case is giving us localhost 3000. Now my other application that we've been working on is not running at all, right? So that's another part of this. It's not running through local. It's going to quite literally go to our production endpoint here. So I'll go ahead and open up localhost now, and I'll go into /API/leads. What I get is not found, but this is coming directly from Expressjs. So quite literally is calling Expressjs, our actual endpoint, directly from a Vercel managed API, right? So this actual endpoint is from Vercel. So just having this alone can allow me to create a custom domain. So right in Vercel, I could just add in a custom domain right now, and that will allow me to have this /API leads. So in other words, if I wanted my example.com /API leads, I could quite literally just deploy it as is. Now, of course, I need to update my actual API itself to manage things a little bit differently, which we'll see in a moment. But the idea is using Vercel with this rewrite is just a quick and easy way to sort of do a proxy service itself, which gives us another advantage as well. Okay, so going back into API and /leads, I actually want to not have it not found, but actually go to those leads themselves. So as it stands right now, the API is at /leads. That's how we designed it. We didn't create a path for API, so we can actually change that destination just like that. We can run it again, and then I'll refresh in here. And now it actually should do an API request to my actual endpoint on AWS Lambda with that Neon database and getting back that Neon data. And of course, I can also post data as well. But overall, what's happening here is it's actually now treating this as just another path, an API path in Next.js. So if you're familiar with Next.js, you'll know that typically speaking, the API itself is going to be that back-end part of things. So I'm not going to go into the Next.js stuff of it. Just this right here, that part is great. So we can also test this. So inside of page.js, I'm going to go ahead and do a quick little test for this. Page.js is just the homepage of our Next.js application, and it's all in React. So if you're not familiar with React, this might be a little confusing. So just bear with me. If it is, I'm going to go ahead and get rid of all of the stuff in between main. Save that and I'll refresh in here. Notice everything's gone. If I put h1 of hello world, save that, refresh in here, and now it says hello world. Great. So all I really want to do here is have a button of some kind that's going to emulate, press me. That's going to emulate that actually calling our API. There's that button right there. Great. Okay, so this is all Tailwind CSS classes in here. So I can do BG green like 500 or 400 to actually have a background. Again, that's another thing that's outside the scope of this, but Next.js has a lot of features that come into it by default, which can make it a little overwhelming to start out with. But the idea here is we want to actually press this and actually do an API call. That's really what I want to see. And to make this happen inside of Next, we're going to go ahead and get rid of this import here. And I'm going to go ahead and pass in the string of use client at the top to basically treat this page as a front end page. Then I'm going to go ahead and bring in something from React itself. We'll go ahead and import use state. And this is going to be from React itself. And then I'll go ahead and do const and new, or let's go ahead and just say data, and then set data equals to use state, and this is going to be just an empty string for the moment. And then I want to actually have a click event in here, so I'll go ahead and do const handle click, which is an event, and we'll go ahead and console log that event. And so we can add in a click handler on the button itself, so we'll do on click, and that's equal to that function itself. Now, this is straight up React. If you don't know this stuff, it's okay. I just wanted to do one simple thing with the fetch call on this on click here. And then the data itself, we're going to go ahead and just say, if the data exists, we'll go ahead and do json.stringify of that data. We really just want to see that it is working as we see fit. So the way we're going to do that is by doing fetch, and then we want to fetch to /API/leads. What do you know? It's going to the rewrite itself. I do not have to put that entire URL in there. Just the destination can be left inside of Vercel.json. So what that does is it allows us to treat this like you normally would in a Vercel application, or a Next.js application in Vercel. I don't really have to think about how to actually handle this. I don't need to think about what URL I'm using or anything like that. But realistically, it's not a whole lot different than calling any normal API itself. But in this case, it's actually going to augment it in a way that's really cool, as we'll see. So now that we've got this, let's go ahead and actually get the data back from this, which I'll just say response equals to await fetch, which means I need to turn this handle click into an asynchronous function. And then I'll go ahead and do set data being await response, response.json like that. This, of course, could have errors itself, which we're not going to handle right now. But overall, I've got a now click event that I can do in here. And let's just make sure everything's running. I'll refresh in my create app, and I'll hit press me. And what should happen, maybe at first it doesn't necessarily come through because it needs to spin up and all that. But after I press it, it will actually come through in there, which we could console log the event each time it's happening. And I'll go ahead and press it now. And you can see that it's clicking, and it actually is doing that call for us. And it's getting that data from our API in a way that's very Next.js based. In other words, the developer, the Next.js developer, if you were working with somebody else, they could just work with their normal development process altogether. And of course, we could post data in here as well. So for example, to post that data, we could just change this method being post, and then the header is going to be our, our content type. And there's going to be application JSON, and then our body data is going to be json.stringify a dictionary here, and that's going to be email abc123@gmail.com. And again, it will still have a response. So this is how I can post data. And of course, if you know React, you will be able to change this as you see fit as well. So let's go ahead and try that out. I'll post out some data here, and there is the result back from it, right? So this is coming directly from my API itself, and there we go. So it's now almost fully integrated here. So that's pretty cool. So now at this point, what we could do is we could actually add this into our repo, which I will. So I'll go git add, and we'll do git first prod deploy, and we'll go ahead and push this into production. And so what's going to happen here is it's going to go into Vercel. It's going to go to the repo itself, and it's going to do all of the build that it needs to make sure that this is working properly, which might take a moment or so. But overall, the idea being that once this is ready, the production application version will be able to use API leads right in there. And we already can, but of course we could then customize our domain and do all that stuff. But once it actually gets fully ready, it will work the way we need it to. And so the way I would actually change our API itself is I would change this to being API/leads and run off of that. So that process would be then git status, git add, git commit, and then updated Vercel endpoint for Next.js API. So I'm basically going backwards now. And so in my actual serverless node API itself, I would then need to add in these paths here, which I already did off the video. And then I would actually have to go back into that application itself, into serverless Node.js API, look at those pull requests, and then we would want to actually commit these things, right? So this is, of course, assuming that the dev stage was correct. I'm not actually going to go through that process, but the idea being that we now release the production version, a new version of the API itself, and really just kind of separating these two things out. So realistically, what our Node.js application is doing is just consuming a pre-existing API. It's not actually deploying our Expressjs application on Vercel, but it is getting close to that. It's getting close to what we might want to do with our application here. And so every time you run a release, it should actually start building out a production version of it, assuming that we are in the right, branch and all that, and it actually does go into our repo. Looks like it has. And so that would take just a moment for the deployments to start filling out right on here. So it looks like my deployment is not actually filling out. So let's go into our settings here and into Git. And oh yes, we need to connect our Git repository. So I'll go in GitHub here, and then let's go ahead and connect the serverless one that we have, which is the API Next. So I'll go ahead and connect that one now. And I might have to run another production push, but there's our main here. And so now we have our project connected to Git, so it actually should do that deployment when I do make those changes. So let's just do a quick change here and just call it a day. And this one, I'll go ahead and say hello world v2, and we'll go ahead and do a commit again and push it again so that we can trigger a deployment automatically. And so that should actually happen now that I actually did that push, and there it goes. So it's now going to build that next version. And by now, hopefully, our API leads is working correctly again. It's still working correctly based off of that new rewrite that we just did right here. And let's go ahead and just refresh that server just to make sure that that did happen. And so I can refresh in here. And all of that happened because of everything we set up with our serverless framework and all of that serverless automation within there. Our production build takes a minute to actually deploy a new version of the API, whereas the Next.js application might take a little bit longer than that. Depends on how big our Next.js application ends up being. But overall, once we actually deploy this, we'll have a new version right on Vercel, as we see here. And now we can visit this, and here's my production version on Vercel, and there it is. It's actually committing and making new data in my API backend, and API leads is definitely showing that backend as well. So great. This is actually showing us how easy and how powerful it can be to start leveraging that API into our projects, into our Next.js projects. The other huge benefit of this is the developer who knows Next.js might not know how you built out this backend, and there it is. I want to point out also, I never actually put any AWS keys in here. I never put anything related to Neon in here. I could quite literally just share this backend, this API, as I see fit and build out my front end. So like if you're working with another developer that's not necessarily on your team, but you want them to build out a feature, this is one of the ways you could do it. You could just send them, whether it's your production API or your development API, you could send them this link and say, hey, this is how you're going to do it. And now you can actually build out what I need, and then we can go from there. Now, of course, you can still use wildcards. There's a lot of different things you can do with these rewrites, so just check the Vercel documentation for that. But this is the methodology I would take to leverage everything we've done to then start actually learning and building out a Next.js application, and then maybe modifying and migrating over to Next.js, because a lot of the code itself can migrate. Not exactly because of how it's written. We've got all this require here. You have to change some of the import statements and all that. But overall, it's like now going towards what you would want to do within a Next.js application, which is really exciting. The final piece that what I want to do is actually deploy our serverless Node.js API itself, this pure API itself, directly to Vercel as well, and just see what that looks like and how, well, it's not actually a whole lot different than what we just did, but it's not going to give us the functionality of that React.js framework. We'd have to worry about that ourselves. So let's take a look at how to do that now. Now we're going to take a look at how to deploy our Expressjs application directly into Vercel. Now this can be combined with what we did with Next.js, but I wouldn't recommend it. Generally speaking, you probably don't want to deploy Expressjs to Vercel, even if it's technically possible. Next.js is a much better alternative, specifically to leverage a lot of the things that Vercel does really well. And part of the reason I showed you the previous one first is because that's a better method to start leveraging your Expressjs application and building off of that. So the first thing that I want to do inside of here is I want to go ahead and add a new project. This project is going to take a few things in here. So let's go ahead and grab this serverless Node.js API, the actual repo itself that we've been using. And I'll go ahead and just deploy this as is. Now, the problem with this, of course, is it's not going to work. It's not going to work at all because of what Vercel attempts to do. So we need to make it work, and we need to change a few things on our project. So the first thing that I want to change is I'm going to go ahead and add in Vercel.json. And let's go ahead and change that to actually JSON. And I'm going to bring in that rewrites again. So this time the destination is a little bit different, and it's going to be a catch-all, and it's going to go into the destination of just simply /API. So in order for this to work, we need to create a folder called simply API. And in this folder, we're going to go ahead and do index.js. And this we need to import using the actual ES6 modules from ... source, and in our case, it's index right there. So what we're importing here is the Expressjs application, which is defined right there. And we also export it, or we need to export it with module.exports and app equaling to app. Just make sure that it is exported so then it can be imported. And then we'll go ahead and do export default of app. Okay. So far, so good. So we did that same rewrite we just did. We also are adding in the index itself, the actual app itself inside of the API. And that rewrite is going to just return everything from that app to the API itself. Okay. Next up, of course, is going to be that we need a public directory. So Vercel is really good at leveraging the public directory to serve the project. So when it comes to Next.js, it actually generates a public directory for you that will then manage all of the front end side of things. Vercel is optimized for front end and serverless in the back end. And we're trying to emulate that here a little bit with just Express. So the first thing I'm going to do is put git keep in here. This is if I didn't want to actually put a front end of any kind, but I'll also go ahead and add in index.html. And then I'll just put in poorly formatted HTML here just to have a hello world call of some kind. Okay, so I didn't actually change this in terms of the Expressjs application itself. It's still using this /API paths here like we saw before. So we might need to change that as well. But the reason I changed those in the first place was really for that integration with the Next.js application based off of a rewrite. Okay, so with this in mind, let's go ahead and change it. We'll do git status, git add --all, git commit, and we're going to prepare for Vercel. And then we'll go ahead and do git push. So what Vercel is going to do is it's going to wait until this is on the main branch. Right now we're working on that dev branch. So what Vercel will also do is, well, it doesn't really care about this production stage at all. It's going to do its own thing. It's going to basically do a similar item of this to deploy it, which means we need one more step, and that is our package.json. Vercel is actually looking for something called build, or Vercel, we'll do Vercel build. It's also looking for a script called build itself. In this case, we're just going to go ahead and do echo the word of simply hello, and that's it. In other words, our build command is not going to do anything. And the reason for this is that maybe we add in another build script in here of some kind, but Vercel build is going to attempt to build something. And if this command does not exist, then it's going to fail. So during the Vercel build command, it does something like our npm run deploy, but instead it's going to be Vercel build if that's available. So we'll go ahead and leave that as is, and then I need to redeploy this again. But to do that, I need to go back into GitHub and specifically into this repo itself. So we'll go ahead and look for that repo, and here it is right here. And so what I want to do is just accept the PR that I just did and commit, pull, and confirm. Okay, and so there we go. Notice that Vercel actually looked at that as well. So I'll go ahead and do another one with git status and git add and then git commit, and then we'll go ahead and do updated script for Vercel, and we'll go ahead and push that. Okay, so it's going to take a moment to build out. So back in Vercel, we actually need to update this a little bit more too, right? So back into our project, we've got our project right here. Well, the problem with our project as it stands is the fact that, well, it doesn't have our environment variables that we need. So our environment variables are going to be related to AWS, right? So the reason we need that, of course, is for that runtime. So let's think about our production stage itself. We've got env.prod, which might have the stage variable in here for prod. It also might need, well, not might, it definitely will need various things related to our secrets. So in our secret library here, we've got the AWS client that's coming through. Now, when we deploy it to AWS, those variables are going to be in there, as in the AWS access key ID and the secret access key. And of course, it also has a role in here that we created specifically for the different stages and all that. But we aren't pushing that into production anymore. So we need to make sure Vercel has AWS access keys itself. So of course, what we could do is we could go into AWS and create some new ones. I'm just going to go ahead and use these local ones that I've got here just so I can emulate or show this example working correctly. And there we go. And I'll go ahead and save this, the environment itself. I don't necessarily need a bunch of different environments, but I'll go ahead and save those variables for all of those environments. And there we go. So one of the things I don't need in this version of my Expressjs application is a Neon API of any kind or my database URL. Because of course, we've already done this, but the idea being that my secrets are now stored on AWS. So if you wanted to get rid of that functionality, you'd have to readjust how you're doing this, and it'd probably be re-adding your database URL as an environment variable. But again, this isn't a deployment that I recommend, but it is one that you could do. The question, of course, is whether or not you should. So now with this deployed, I see that it does say hello world. So it looks like I'm on the right track. That hello world, of course, is coming from the public index.html here. So let's go ahead and visit this. And at least the front end is going to work here. So we've got the front end working, which is kind of cool. I want to visit the actual main deployment as well. So let's go back into the project and grab the actual deployment URL, which is this one right here. And so there we go. And now I'll go ahead and jump into the API/leads. And if I did everything correctly, it will work. But of course, the problem that it is facing right now is merely the fact that I didn't have those environment variables when I deployed this version. So let's go ahead and just create them now. I'm going to go ahead and update my index page, and we'll go ahead and do P and env working. Try this again. And actually, one thing I might need to do also is just verify any pull requests that I have in here. So this will also trigger another deployment. So I'll go ahead and run that. What this will actually do is solve that environment variable thing. So I probably don't even need to submit this yet. So I'm not going to do that yet. Let's go ahead and see if this recent deployment solves the environment variable thing that we had with Vercel. So going back in here, we'll just go ahead and take a look at the deployments that are coming through. And of course, it's building one. Notice it doesn't take very long. That's not surprising because it's only installing a few things here. It's not using the cache in the same way that AWS Lambda is. It's literally installing all of the things in our package.json all over again. And there we go. We've got a new production version. So I'll go ahead and open up my app again. I can actually just go back into this URL here. And if I refresh, now everything's working. And there is my Expressjs application running on Vercel. So what we could do is, yes, we could keep this. I don't recommend it, but we could keep it and then build out your front end using something different. So Expressjs has a lot of different front end support as well. In other words, the index.html could then bring in something like Pug or some other JavaScript that you might want to have in there that then calls the API itself. But that starts to get way too complicated. Then it's like, oh, you might as well use Vercel if you're going to start building out the front end itself, Vercel and Next.js, to build it out and make it even more powerful. But I really wanted to show you how those two different approaches worked so that if you wanted to use something like Vercel to deploy your applications, you totally could. Now, all of this is possible because of how easy it is to be flexible with our deployment options. Neon is well suited to do all of that for us, right? So the fact that our database, we didn't have to touch our database at all for those last few deployments was so nice. And that's because of how we configured everything to work in this like automated fashion. So when it comes to deploying to Vercel, the other part of this that you could consider is you don't always have to have your database URL exposed inside of the application itself. So even if you were using Next.js, you could still use the parameter store that we did. And then in your workflows, you could still do the dev stage where you would basically stop, as far as the dev stage is concerned, you would create a branch, maybe the deployment branch. You could then also create that pull stage. Actually, everything in here, with maybe the exception of deploying a development stage on AWS, could still work in a Next.js application. And Next.js itself can also do a bunch of things with that. And of course, if we wanted to deploy our development version on Vercel, well, we could go back into Vercel, into our project here. The first thing that I need to do for this project is jump into the settings, go into my environment variables here, and we want to add one specifically for a preview environment. And I'll go ahead and grab the branch itself, which will be our dev environment. I want to go ahead and add the stage of dev, right? And then we'll go ahead and save that. So now we've got a preview environment on that stage, right? So it's going to give us that dev there. So the next thing that I would want to do is jump into our deployments here. And we're going to go ahead and create a new deployment. So it's going to be commit or branch reference. This is going to be dev. So let's do a quick search for the dev branch. There it is right here. This happened just a little bit ago. I'm going to create a deployment for that. And this should work, right? So it's going to be basically the same thing, just using the dev branch itself. So in other words, the branch itself should also have the same data that our production one has because, well, we've been deleting and recreating those branches. But overall, what I really want to see here is that the dev branch actually works, and it is something that's different. And again, it's just another way to just branch out our database, do some tests and preview environments and all that. So here it is. There's our preview environment. I think it's working. So let's go ahead and give this a shot by looking at the domain itself. And so there's our hello world. Let's go into our API, just make sure that that's working. So API leads. And what we should have in here is something maybe slightly different than the other one. This has 18 values in here. And so once again, I could just go back into this one. Let's go ahead and just create a preview or a staged version. I'll go ahead and update this and go ahead and do staged version, and we'll go ahead and push it. Okay. So of course, one of the challenges with pushing this is the fact that I have my dev stage here is going to quite literally create and delete a branch, which could cause havoc or issues with staging this version. So it's not necessarily something I recommend doing, but we could try it out just to see that you can absolutely deploy different versions of your application with different stages and different branch databases at that time as well, which in our case, the stage version just came out 20 seconds ago, so we can go ahead and take a look. I'm not confident that the API is going to work here, but we can give it a try. At least we've got some other text in there. So let's go ahead and grab in the /API and leads. And I would imagine that it's either going to work or it's not. In this case, it did work, which is great. So we have the ability to now also have those different stages as well on Vercel. And each stage can have a different domain, as well as the main production one can also have its own custom domain, which is maybe one of the main reasons you end up deploying to Vercel as well, is because it's quite a bit easier to put a custom domain on Vercel than it is on AWS and the serverless environment. So yeah, that's pretty cool. I think Vercel is a great tool, and now I would recommend that you start modifying and converting all of this stuff to Next.js, which is really the next part of so much of this. But even if you didn't, we now have a really solid foundation for an API service that we can start building out a lot more endpoints if we needed to. Hey, thanks so much for watching. Hopefully you got a lot out of this. Now I want to leave you with two challenges. One is, how do you actually implement authentication? whether it's users or other applications. How do you actually secure our API more? Now that will be a really good challenge to undertake at this point if you were able to get this far. The other one is, well, how do you actually convert this Expressjs application into a Next.js application? Those are the two challenges I want to leave you with. They are fairly straightforward, especially because there's a lot of third-party support out there. But I think those are really good challenges that you can undertake. And guess what? They can feed into each other as well. So thanks again for watching. My name is Justin Mitchell. I really enjoyed sharing this with you because I think serverless is one of the most fantastic things that you can learn about and implement, because it really just helps us focus on just our code. We don't have to worry about the infrastructure. That infrastructure is taken care of by the different services that we leveraged, right? So AWS Lambda will scale up if we get a lot of users coming in. So will our Neon database. So would Vercel if we went there. It's really, really great to just focus on the code itself and not really worry about the infrastructure. That is one of the keys of serverless, and that's why I wanted to create this course for you. So thanks again for watching, and I look forward to seeing you again in the near future. Take care.